Hello, friends, hackers, red teamers. I do not need you to lend me your exploits today, because today is a special Frustration Friday. Today, I'm not going to be frustrated at all. And the reason is because I have been frustrated pretty much for the last 7 days-ish. And I'm going to be sharing the results of my frustration with you. Today, we are going to go over 10, hopefully we'll fit in 10, challenges from the recent HackTheBox CTF. There are going to be 3 crypto challenges. There are 7 web app challenges. I have all the files. I have all the Docker images. I have prepped for 2 hours yesterday to make sure everything seems to be working okay. So fingers crossed, everything will work. But yeah, if you are interested in any of the solutions to the CTF, or even just interested in how CTFs work, this is a good stream for you. Obviously, I am what I recommend for CTFs, if you're going to do a CTF, join a team or find some people and form a team, because it's so much easier to bounce ideas off each other. Hardly any of these challenges that you'll see I solved purely on my own. I have to give credit to a bunch of people in the OnlyFeet hacking team, which is the CTF team I'm a member of, for basically being online with me 4 hours randomly on Tuesday evenings, just trying to figure out why our payload won't work. Definitely recommend if you are interested in doing CTFs, and obviously I recommend you do CTFs because they usually show pretty clever exploits, while at the same time being solvable. So there's some challenge there, but there's also some education to be had. So let me switch to my screen a minute. This was the CTF, Cyber Apocalypse CTF 2022 Intergalactic Chase. It was slightly odd. It was a themed one. I didn't much care for the lore. Each challenge had a little paragraph of lore behind it, but to be honest, I don't think any of them actually made any impact on the challenge itself. Oh, so that was interesting. But yeah, we came 23rd out of, I don't actually know how many teams, but I think there were over 6,000. So yeah, I mean, there's the first 3,600 there. So yeah, I think we did pretty good. We got some people in chat. No thing. Hello, the Soakin. Hello, Christy. Always good to see you. First time chat from Bellacore, Frago780, Jean Astruc, or Jean Astruc, Regis Philburn. Hello, Hexorcism666, Ricard, Kettle Bear, Dora404. Finally made a stream after 6 months. Wow. That's a lot of dedication, so thank you very much for being able to attend. Hello, Soradator. Helloran. Awesome. How was everybody's week? Firstly, mine was as I'm about to show you, quite frustrating. So yeah, we'll wait a little bit. We've only been streaming 5 minutes ish, so I want to see if we can get some more viewers. So actually, one thing I should do is start Stream Raiders. Okay, so there we go. you haven't played Streamers before, it's a free game. It's a 0-player game. You basically just have to follow the link in chat, sign in using your Twitch account, and then every 5 minutes you'll hear a little chime to remind you to place a unit. And then after 30 minutes, we will fight a battle. It's something to separate the monotony of solving CTF things. Sean made it in top 50 of your country on this on Try Hack Me. Nice. That's just really impressive actually, because Try Hack Me has like 100,000 users, so that's crazy. Well done. Okay, I tell you what we'll do as well. We'll play one game of marbles while we wait. So, there we go. We haven't played Convergence before. So again, those who don't know what marbles is, again, 0-player game. All you have to do is type !play in the chat if you want to enter a marble, and then it's a riveting experience as we watch the marbles sort of go down this weird course. So I'll start it in 60 seconds. You can still join while the countdown is ticking down. A gift sub if Hat and Dog wins. Well, thank you. Alright. 30 more seconds to enter. Again, it's a lot of fun watching your marble collide with other people's and run down the track. Kettle Bear is matching Hat and Dog's gift sub if he wins. Alright, well, let's see if Hat and Dog will be lucky. Alright. Well, this is an interesting contraption. I don't know exactly how this works, but we'll, I guess we'll back out. Oh, okay, we're going to go up again. Interesting. Looks like... Oh, Hat and Dog is in first place right now. So let's follow him, see how he does. Oh, lost some speed there. And then he got overtaken by Jean. He just leapt. But again, it all depends, because you can get a really slow route. It looks like Jean's still in the lead. He's miles ahead. But this can slow you down. Dora. F's in chat for Dora. F's in chat for no thing. F's in chat for Christy. Poor Christy. Oh, who is... Oh my goodness, who was that? It's Ahmed29. Just came out of nowhere. But how did you get that much speed? Sean's like all the way back here now. Rickard just over... Oh my goodness. Fraggle. So many people just overtaken. Craziness. That was insanely fast. I think, yeah, Hat and Dog fell off at some point. We lost Hat and Dog. Well, here we go. I think Helleran's in 9th place. Respectable last. At least you didn't come last technically, because about 4 people fell off, I think. There you go. Well done, it's Amid. All right.
New subscription received. Dispensing gratitude. Gratitude dispensed.
Sure. Thank you so much. Jean gifting 10 subs to the Empire. Welcome to Jeff Kang 2, Super Lolly 11, One Batman, Jay is Uman, Not Now, or Not Now, I guess. Not Zero Famous, Alfred the Sixth. That is an impressive mixture of Leet and Roman numerals. Nolopter, Nefarious, and Wild Agar. Thank you so much, John. Well, you know what that means. We have to give you 10 spins. For those of you who are new to the stream, I'm just going to write down John's name so we understand. He has 10 of them. For those of you who are new to the stream, every subscription gets a spin on the wheel. And you win. So we probably won't do all 10 at once. We'll do a few. So there are a few. Till my terminal was disabled last stream using the remove a category option. But you know, we got some good ones in here. Type with one hand for 5 minutes. Hack without glasses, which is always funny. Cat time. Reverse course giveaway. There's some good ones to me. So you know, everyone's subscribing to my YouTube. Always good. All right, so let's spin the wheel. Well, 2 times the next spin. We're gonna have to spin again, obviously. So let's see what it lands on. 2 gift subs to chat. Okay, here we go. And that also means 2 new spins. All right, so hang on. I'll put me down for 2. Let me just go. How do I gift sub on here? I think I need to go to my actual. It's really difficult to gift yourself subs without going to your own stream, I think. I'm gonna have to mute my stream. There we go. Pause it. Gift sub. Okay, gift anonymously. How do I do custom? There we go, 2. Okay, 2 gift subs. Complete. Should go through. There we go. Welcome, Lucifer and Damien MZ40. I can type gift to in chat.
Received.
Ah, nice.
Dispensing
Thank you
gratitude.
very much.
Gratitude dispensed.
Dispensing gratitude to myself. Thank you. All right, well done. Let's do one more spin. So we're back to 10. We'll do one more spin and then we'll move on with the content. Chat tweets. All right, Jean, because this was technically your spin still. You need to tell me something I should tweet. Obviously, within reason. I have veto powers. But if you want to plug anything, if you want me to just tag you and say follow this cool dude, whatever, you know, let me know what you want me to tweet from my account, and it will be done. All right, let's move on to an actual challenge. So we're going to go through the crypto ones first. So first, mostly because I actually secretly really enjoy crypto stuff. It's kind of just fascinating. So hopefully I can share that with you. So if we go into the first one, so this was all the ones we're going to do were, I think, 1-star, like they're easy. So not too difficult. So I believe the source. So if you don't know how a CTF works, sometimes you will get source code. Sometimes you won't. Sometimes you'll just be connecting to a machine. You'll have to figure it out. A lot of these challenges, in fact, all the ones that we're going to do today, had source code. So it's good because we can analyze it at least. Putin, I think that's how you... Yeah, Putin, did you solve the web challenges in an unintended way? Funny story. Yeah, we solved 3 of them unintentionally. One of them I'm going to show you. One of them is actually unintentional after the fact. So I discovered the correct way, and then I read the source code and figured out another way, which was easier. One of them, 2 of them, we completely cheesed. And one of them I'll show you another cheese, because technically I haven't actually figured out how to solve it. I mean, I figured it out, I just cannot get it to work. I'll tell you about it later. So we'll show you some cheese. Okay, so the way this one worked, you got a oops, I don't want to do that. I want to split my terminal. So you connected to so you got the source code, but the source code runs why am I blanking? It runs a socket, so you can connect to it using NC. So we get this debug message generating global DH Diffie-Hellman parameters. G equals 2, P equals this long value, calculation complete, generating the public key, calculation complete. And then it says enter the public key of the memory, right? And then it will, I think I'll ask you for something else. So let's actually analyze the code here. So I have put the flag in here. Obviously, when you downloaded the source code, you didn't get the flag. It was replaced. This stuff was replaced. But because we're solving them, I put the actual flag in there. So this is just setting up the socket. That's easy enough. This is more socket stuff. There's a send message feature which takes the socket and sends the message encoded. Okay. Receive message. Receive message sends it and also returns the response. Alright, so I guess receive message is when you want to do this. So it will send this message and it will grab the response. Decrypt. So we have some decryption going on. We have a key being generated from a shared secret. The cipher is AES. It's in ECB mode, which is a really basic mode for a cipher. It takes the message and it decrypts it and returns the message. Okay. So here's the main function. So we have send message. This is what we saw before, right? So it calculates GMP. We know GMP. Generating the public key. So it grabs the C value, which is in a random... So it's a random number, an integer, between 2 and P minus 1. So whatever this P was. So between 2 and this is quite a lot of numbers. And I think that's going to be the... that's going to be one of their secret keys. Then it calculates big C using POW. So the way POW works, it takes G, so G is an integer, and it raises G to the power of C. And then if there's a third, it'll do a modulus. Does everyone understand what a modulus is? I guess people who don't understand what a modulus is, if you've ever done clock arithmetic, it's where, yeah, it's pretty much the remainder thing. So the easiest way to describe it is you would so you go g to the power c, and then you would divide by this p number, but you would take the result as the remainder. So if we had, for instance, let's say 15 modulus 10, right? Well, 10 goes into 15 1 with 5 remainder. So 15 modulus 10 is 5. Okay? And you get some quirks, so like 2 modulus 10. So 10 can't go into 2, so you just actually get 2 out of that. Does that make sense? So 10 goes into 2 0 times, and since we get a 0, there's 2 left over. So that's the only other one you really need to know. Okay. So it generates this C value using 2 values we know, right? G and P, but 1 value we don't. And then it asks for the public key, which is capital M. So this is what we give it. It makes sure that this is an integer. Okay. And then it generates a shared secret by taking M and raising it to the power of C modulus P. Okay. Then it encrypts the sequence. Encrypted sequence. So it asks for an encrypted sequence. Okay. And then it tries to decrypt it here using the shared secret. And if the decrypted secret is this, we get the key. Okay. Is everyone following along? So this one was actually mind-bogglingly simple. All we need to do is we can control this shared secret, right? Because we can control M. The problem is we need to know the shared secret because we need to encrypt this string in order to send it as the encrypted sequence, so that when it decrypts this encrypted sequence, it will give us the flag. The problem is, how do we know the? No, you haven't missed that much. We did a lot of marbles. Well, we won one game of marbles technically, and we've been talking a bit. So we need to know what this shared secret is. The problem with this is we only know what M is. Well, because we can control M, we can do anything with M. But we raise it to the power of C, which we don't know. Modulus P, we do know, right? This actually turns out, if you think about it, we need to get, so X equals something, we'll call it Y to the power of, and this is unknown, right? And we don't really care about the modulus. This is all we need to care. This is all we care about. Now, we don't know what this value is. Is there any value of Y we can give where this value doesn't matter? This is now turned into a math quiz. Is there any number that we can use as a power where it doesn't change the base number? Right, 0 or 1. 0, 1, or both, fine. If this is a 0, right? 0 to the power of anything is 0, right? So we don't even know what this is. And 0 modulus P is going to be P, right? So we can't actually, I mean, we can use 0, it's just going to be annoying. 1 is better. Right, yeah, sorry, 0 to the power of 0 is 1. Anything to the power of 0 is 1, which is another thing. 1 is actually better here because 1 to the power of anything is just 1. if you modulus P1, you'll always get 1. Right? So 1 is better here. So all we need to do is use generate a secret key. So we can generate the secret key down here by just doing 1. We can just do 1 to the power anything modulus P to get the shared secret, and then we can encrypt this string, and then all we need to do is send it. So actually that's what I've done here. So I grabbed
New
P.
subscription received. Dispensing gratitude.
Prime D,
dispensed.
thank you for the Prime sub. All right, we'll add you to the spins. We'll do some more spins after this. Prime D. So I wrote this quick encrypt.py. So all it does is it's pretty much just takes the decrypt. Where is it? It takes the decrypt function and just reverses it, so it just encrypts it instead of decrypting it. And then we get C equal to whatever. C can be anything. Let's just set it to 1. M we want to be 1. So now it's going to generate pow M to the power C, so 1 to the power 1 mod P. And then we're going to encrypt this, and it's going to print out the hex for us. Okay, so we will do that. So what I'm going to do here, and actually over here, we'll do Python 3 encrypt. Log to bytes is not defined. Guess I didn't run this code properly. That should be easy enough. We just need to copy this line. I guess I moved it at some point. Okay, so now we get this. This is the encrypted message. Okay, and so now if we connect back here and give it 1, right, as the public key, and then we paste our message, well, look, there's our flag. Any questions? That was the easiest crypto one for a reason. You just had to realize that you could put 1 because it doesn't matter what C is. It's a very basic math thing. Okay, let's do some more spins while people ask questions. We're still on Jean's spins. Jean getting 2 times the next spin. All right. Did you decide what the tweet was, by the way? We have to scroll up. Marble race. 2 marble races. Okay, here we go. I'll make a 2 times marble race. All right, we'll do one of them. We'll have to separate these out a bit. I'm trying to find you in chat. Just your favorite pic of your cat. Miss mine like crazy. Okay, I will tweet that at some point. Okay, we'll do. Let's do one more spin and then we'll do a marble race. So we're down to 8 spins. Still on Jean. Very generous. Okay. Alright, Jean. Well, the marbles, well, we played marbles. Come up with a category to add. Let's switch back to marbles. Express delivery, sure. Alright, everybody. Those of you who have joined since we last played marbles, exclamation point play in chat to enter a marble. You don't have to do anything. It's basically just a physics game. It's a fun physics game. Well, I'm going to start the 60-second countdown. You can still join while the countdown is going, so no worries there. Were there any questions? Well, cyanide for dinner, which is not recommended. What's up? How goes life? Life is okay. Thank you for joining the stream. I think everybody... There's a stream delay? Ah. How long is the stream delay? Not entirely sure what's going on with this one, but we'll see. Oh, okay, it's just the mechanism to get to the middle. Just the guy's almost down it, I think. Where's Rickard down it? Yep. All right, Rickard. Oh, we've got quite a cluster. Here we go. Rickard managed to avoid. Oh no, there's freaking portals. Oh god. What is this thing? Oh, Rickard missed all the portals. Hat and Dog coming up. But Rickard makes it through this one. Okay. Rickard's pretty much just... Yeah, he's in quite a big lead right now. Oh, F's in chat for Hellaram. He fell off the world. There's the end. No, it's coming up. So unless... Well, actually, Nefarious has some speed. I don't think one of these is shorter than the other. I think Rickard has it. That was close at the end, though. Well done, Rickard. Oh, I got fourth. Respectable fourth. Alright, you guys do have a minute to finish. So, should we go check on who's in last place? Did Gar get in? No, there's Gar. There's Gar. Poor Gar. Alright. Well, Oreo Bite. I'm gonna follow Oreo Bite. I'm not sure I can even follow him because I don't know how to follow people other than higher than 10. I'm not entirely sure how that works. Here we go. Which way are you gonna go? I'm gonna go this way. Okay. Alright. Made it in with 10 seconds to spare. Alright. Okay, so we have one marble race left. All right. Let's move on. So there weren't any questions about that, right? Good. All right. Right. We can move on to something slightly trickier. Jenny from the block. All right, let's look at Jenny from the block. Let's look at her source code a minute. Don't need that, but hold up. Okay, Jenny from the blog. So firstly, there is this, the flag was in this secret.txt, so I don't even need to show you this. Stream readers? Oh, okay. Yeah, let's do stream readers. Okay. Let's recurse this guy. Okay. I'm not sure why we're attacking houses, but I guess. Here we go. Put on Fraggle. Like a few things. Okay, and we'll move this one. Centurion. Okay. Back to the screen. Evil houses. Okay. All right. So the source code for this one, allowed commands contains who am I, ls, cat secret.txt, and pwd. Block size is set to 32. If you don't know what a block is, so there's pretty much two types of encryption algorithm for symmetric, what's called symmetric encryption. There's a stream cipher and a block cipher. The difference is with a stream cipher, you pretty much just perform the encryption on each byte that goes through in turn. Technically each bit. With block ciphers, you first separate out the message into blocks of a fixed length, and then you encrypt the entire block using some algorithm. Okay. There are various reasons why this is better than stream ciphers. I won't go into them, but you can get more secure encryption by using blocks. However, there are definitely bugs that you can avoid. So there's an encrypt block function which takes a block, takes a secret. It generates an empty string encrypted block, and then it says, so for I in range, so that's going to be 0 to 31, it's going to calculate a value, which is the item from the block. So pretty much for this one, for when I starts at 0, this is going to be the first letter of the block. It's going to plus that to the first letter of the secret. So these are bytes, so you can technically, plus them together. And then it's going to do modulus 256. So we're going to get an answer between 0 and 255, right? Which just happens to be, a byte range. Then it adds the bytes to the encrypted block and returns the encrypted. Okay. So that's pretty simple. There's the encrypt function, which takes a message. This will be the entire message, and the password. It creates a SHA-256 hash in hex of the password. Sets to H. If the message is less, so basically this is saying if the message is less than the block size, it's going to pad it. In this one, you don't really need to know what padding is. We'll get to that in a minute. But padding effectively makes sure that every single block has the block size characters in it. So even if you send a block with one character, the entire block will still be 32. Okay. And then it seems to split. So this looks kind of crazy, but all it's really doing is splitting the message into a list of blocks. Okay? So what you get here, blocks, is just going to be a list of 32 character strings. Okay? Then you set CT to an empty string. You iterate over the blocks, and you encrypt the block using the SHA-256 password here. But then, notably, you then overwrite H with the SHA-256 hash of the encrypted block that you just encrypted and the plaintext block. And then you basically append the encrypted block. So this is an interesting one. The first block is going to be hashed with the SHA-256 hash of the past. Sorry, the first block is going to be encrypted with the SHA-256 hash of the password, which we don't know. I presume we don't know. Yeah, password's randomly generated each time. Okay, but then every subsequent block is going to be encrypted with the SHA-256 hash of the encrypted block plus the plaintext block. Okay, so that's interesting. Let's see what happens when we actually run this. So go back. Let's run this code. Python 3 shall clear this out. Python. Oh, we don't Python. We need NC. This is Jenny. Welcome to the debug terminal. For security purposes, I will encrypt any responses. I mean, we can just put an A there. We get this. But it looks like there were some commands that we could run. So let's do who am I? And let's do cat secret. Okay, so the first clue is what's happening here is obviously who am I is going to be technically just Tiberius, because that's who we're running as. But this is way too long to be just Tiberius. Okay, so we'll look into that. But also, cat secret is way longer, which means the whatever's in secret is longer than Tiberius. Okay. So if we go down here, we take the command is what we send. It then runs the command, which this function just double checks that the command we've given is in the allowed commands, and then it responds with the output. Then it creates this string, command executed : space command plus a new line plus the output of the command. And that's what it encrypts. So let's copy that information. So we've got the string. I'm just going to take out the apostrophes here, because we know what these values should be. So when we did who am I, right, we got, and this is I'm just going to put unknown. Technically we do know what it was, and I'm going to replace this with actual new line. We know what it was because we're running it locally, but suppose we didn't, right? So we've got this. How many characters is this? This is 24 characters. So this is going to be in the first block, and then the new line character, and then pretty much all of this is just going to be one block. So that doesn't really help us. But if we use the cat secret.txt, look what happens. If I select all this, you can't see it down here, but this is exactly 32 characters. So what does that mean? It means the first block is 32 characters, right? And we know the first block's plaintext. We also know the first block ciphertext, right? It's in here. It's the first, technically the first 64 characters, because this is all encoded hex, right? The first 64 characters here are the encrypted version of this string. Do you see what happens now? We know the plain text of the first block and the ciphertext of the first block, and that's all you need to know to decrypt the next block. And then once you've decrypted the next block, you know the plain text of that block, and then you can decrypt the next block. So we can, by knowing that this is 32 characters, by knowing the plain text here, we can actually just decrypt everything. And I wrote some code to do that. So let me expand it a little so you can see it. So this is just a decrypt block function, which pretty much just reverses the encryption process. You don't need to worry about that. It's pretty easy to figure out. So I have a block isn't a line of code, no. A block is just a number of bytes. In this case, 32 bytes. You can set the block size to pretty much anything you want. It's not technically the case in most encryption algorithms, but in this case, you can set it here. Okay. So, we have, well, I should probably just open it in the editor. It's going to be much easier to see. So we have our known plain text, right? This 32 character string. And now we need the blocks. Well, here's all of the blocks together. So if I put this in here, now what I can do is I can, remember these blocks, even though the block size is 32, because these two characters here represents 1 byte. So the blocks here are actually 64 characters length. Okay? So you can use some fun little code here to do 64 and then just replace that with that. Okay, we don't need that last one, but now we have basically a list in Python, and we're going to put it in here. Okay, so for those not following along, this block, this encrypted block, is this, right? This encrypts to this, right? So all we need to do is take this plain text, append it to this, right? And that's the key to decrypt this. And then we just repeat. We take the decrypted version of this, we append it, and that's the key to decrypt this. Repeat that, blah, 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 blah. Okay? And this code does all that. This is a pretty simple, but you can see here, I just basically take the bytes from hex of the 0th block, the first block, plus the known, take the digest of that, decrypt the block, set that to known, and then basically repeat the process. So if we run Python 3 decrypt, that's what we get. And we can actually verify that because I can cat secret here, and look at that. It's identical. It's just a bit mangled by the thing. But there's our flag. Are there any questions about that? Hey, Master. Glad you could join the stream. If you have any questions, ask them now. In the meantime, we'll do some more frickin' spins because we have to get through these spins. We have 8 spins left. We're still on Jean's last 5. Type your questions in chat if you have them. Right, Jean. We need a new stream title. Please choose one and put it in chat. I think if you don't mind, I'll tweet my cat out after the stream just because I need to find a good picture. Oh, look at that. We'll do a marble race. Technically 2 marble races now we need to do. We'll spin the 3rd time. Now you're down to 2. We're down to 5. Okay, this is going to be interesting. I think we're going to have to spin again for this one because I don't think I can do these banning my tools. If you don't mind. Yeah, I'm gonna take the. Actually, I'm gonna take some of these out. We can't do reset the box because that makes no sense. Really, none of these are actually boxes. We'll take tool ban out. I think everything else is fine. All right, so we'll this will be a respin. No worries, they'll go back in for next time. Well, look at that. We get some cat time. Okay. While I go get the cat, if you have any questions, chat can choose a title. There we go. Jean, which cat do you want? Do you want Aria? Do you want Raven? Or do you want Tiri? I'm gonna get freaking hair all over my nice black shirt as well. I think I got a cut on my lip. Really annoying me. Raven. Alright, I will go get Raven. Any questions about what we just did, by the way, please put them in chat. Do not be afraid to ask questions. If you don't have any questions on this one, you're gonna have questions on the next one, I promise you. The next one, the complication goes up further. So, but it's a fun hack.
New subscription received. Dispensing gratitude. Gratitude dispensed.
Brought Raven. Gar 7, you crazy man. Thank you so much. Okay, let me He's Raven? Gar promised me these subs yesterday on his stream, so he's very kind. Hey Raven. No. I know. Look at her eyes. They're so cute. Look. They're actually orange. They're basically pumpkin orange. They're kind of crazy. Alright. I'll let you go. You go. I also got something to defil myself. There we go. Much better. It's a she. Okay. Alright, what do we I need to freaking scroll up. Right, so I'm gonna have to add. So back up to 10 spins. Gar 7 has 5 now. Nice. Okay. Okay. Right. So, are you allowed to use that sticky roll? Why not? Did someone have a name for the stream? Did we come up with a name for the stream? Okay. So actually, let's go. I still need a name for the stream, chat. Crypto. Three-eyed Oracle. This one is insane. Hog stream. Sticky roll. Okay. I'll do Tib uses a sticky roller. There we go. Update. Tib uses a sticky roller is now the name of the stream. Okay, right. Let's go back into Atom. Close some of these. Okay. So hopefully my explanations have been okay so far. This is where they might break down because this one is insane, honestly. Crypto has always stood for cryptography, and nobody is gonna convince me otherwise. When someone says crypto, the first thing that pops into my mind is cryptography. No, we haven't missed the web. I wanted to get the crypto out of the way because honestly, because of this one. Okay. So again, I've put the flag in here. We did not have this in the challenge. This was redacted. We have a prefix, which is a random 12 bytes. We have a key, which is a random 16 bytes. We have an encrypt function, which takes the key and the message. It looks like the message is hex encoded because it basically says take the bytes from the hex. It then sets up a crypto object, which is basically just AES in ECB mode. ECB, by the way, stands for Electronic Codebook. The reason being, all it does is it takes each block, and just like you would in a code book, you would look up the value of that message when it's encrypted and just use that. So to give an example, say you had a block that was just 4 zeros, right? It's a 4 block thing, and that encrypted to, I don't know, let's say A5BF, right? And we had another block, 1111, and that encrypted to, I don't know, what should we do? C2B1. Okay? So if you have a string, which is 00001111, okay, I think it's pretty obvious that this encrypts.
Received. Dispensing gratitude. Gratitude dispensed.
Damionos, thank you for the Prime sub. Right, we'll add that. We'll add that to the spins. Damionos. Okay, so I don't think it's unreasonable to say that this will encrypt to C2B1, right? Does everyone understand that? Okay, so the key thing with ECB mode is that all blocks that are identical will encrypt to the same thing. So 4 zeros followed by 4 ones followed by 4 zeros will encrypt to this. Okay? ECB mode is never recommended. Okay? There's a great Wikipedia article. ECB cipher mode. Here it is. So it uses Tux, the Linux mascot. Let me zoom in. So this is the original image. Oh, I should probably move this. There we go. This is the original image. This is it using basically a non-ECB cipher. And this is it encrypted using ECB mode. Can you see why ECB mode kind of sucks? Because it turns out, even if you separate this into blocks, there's a lot of identical blocks in here. There's so many identical blocks that you can still kind of see Tux there. Yeah, he looks horrible, but you can see him. if I was to show you this image and you knew what tux was, you would be able to tell this was tux. Okay, so that's why ECB mode sucks. However, they're using it here, which is nice. So this is where padding comes in. Now, effectively what this is doing, it's taking the prefix, it's taking the message, and it's taking the flag, and it's putting them all into one string. And then it's saying, okay, we're going to have 16 byte blocks. So pad this until you're a multiple of 16. Okay? So that effectively means, so if we know that there's a prefix of 12 characters, right? So for argument's sake, let's just say they're ones. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Then there's our message, which we obviously know the number of bytes, and then there's a flag. And we don't know the number of bytes in the flag. But let's say our message is 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 10. And let's say the flag is, I don't know, I'm just going to spam Fs. Okay, the flag's that. So when the program gets our 10 zeros, it's going to prefix it with the prefix. It's going to put the flag on the end. And then it's going to split it into blocks of size 16. So where are we here? So that's the first. So that's the 13th, 14th, 15th, 16th. I think that's 16. Maybe not. That's 16, right? All right. So yeah. So it's going to do this, right? But then you've got these 6 Fs on the end, and obviously this isn't 16 bytes, but we need 16 bytes in every single block. So it's going to pad it, and I'm not going to go into the details of padding. It's kind of complicated. But effectively, there's a unique set of characters that gets put here, which tells the cipher that it's padding and also how long it is. Okay? Now, crucially, something to keep in mind, at least when dealing with this kind of cipher, if the message is exactly divisible by 16, right, you may think, oh, there's no need for padding, but you'd be wrong. It will put a block entirely made up of padding, whatever this is, right, here. Okay, that's just something to bear in mind. So, now that we got that up. So it pads it, so it's going to be a multiple 16, and then it encrypts it using the cipher, and then it hexes it, and then it probably just sends it back, right? Yeah, so here we go. So when we connect, we send a message, and we're going to send the message in hex because this is what it expects. It then encrypts it, and then it sends it back, encrypted. So actually, let's see that in action. Python 3 challenge NC localhost. Okay, so I mean, let's just send 001122334455. 66. Okay, so we know, right? Let's copy this. This was our encrypted string, and 6, yes. So we know here that the first 12 bytes of this, right? So because this is all hex encoded, we need 12 bytes actually. Yes. So the first 24 bytes here, because it's hex encoded. So all the way up to this 8. This is our prefix. So I'm just going to put P's for prefix. Okay. We don't know what this is, but we know it's 12 bytes long. Then comes the bytes of our message, which, what did we use? These. Okay. Which means that's our flag. Okay. 58 divided by 2 is what? 50 divided by 2 is 25. 8 divided, so 29.
New subscription received.
Which I think
Dispensing
is
gratitude. Gratitude dispensed.
25. Oh, plus the padding, obviously. So this is the flag plus padding. Ghosts are spooky. Thank you so much, my friend. Welcoming Ricard, Deltri C, Static Noise XYZ, Santos R2, Guxor, Orbital Gun, Helen of Tor. Hey, Helen. Infosec House, Ghost and Keys, and Hexorcism 666. Welcome to the Empire. Don't you need to double the length of your own message since each byte you send is 2 hex characters? No, I sent these. I sent these as hex, so these are hex typically. So this is a 7-byte message, right? We're counting from 0 to 6. This is 7 bytes, and because this is all hex as well, it matches up perfectly. So we know here that this is the flag plus padding. Okay. We don't know how much padding there is. Actually, I tell a lie. We do know how much padding there is because we can figure it out. The 16 bytes. So if we go all the way to 32, that's 32. That's 32. So basically, we can do that.
New subscription received.
That.
Dispensing gratitude. Gratitude dispensed.
Okay, and if I go here, right, that worked out nicely actually. Actually, yeah, we don't know how much padding there is, but we know that this is from here is the flag, and at some point there's the padding. I think you can actually work it out by just continually adding until it overloads again. But we're not going to do that. Agent OP, thank you for the tier 1 resubscription. 2 months. Welcome back to the Empire. Okay, so you're probably asking how the hell do we solve this? Does anyone have any ideas how we solve this? Firstly, I'd be interested if anyone has any ideas at all. Because all we can do is send, right? This is pretty much all we can do. We can send a message and get the encrypted version with the prefix and the flag, plus some padding. Any ideas at all? And while we do that, I'm actually going to send some more data to it. I'm just going to send them decode it before it's. Well, we can't. We don't have control over the. We don't have control over the code. So even though I'm running this locally, in the CTF this was not run locally. Alright? So we know there's... So I'm just gonna separate them out. Stream raiders. Oh, yep. Okay, we'll do stream raiders. All right. I want some thoughts in chat. Mid-patch update. Wow, really? Well, I'm stream raiders. Bonus tech. We'll do a marble afterwards then. Okay. New battlefield. Where are even the units? I guess they're over here. I want some ideas. I want at least one person to have an idea. Alright. Open Captain chest. Well done, Jessica and Christy. We want to finish the chapter. I'm gonna use one of my. I'm gonna use a necromancer. Okay. An idea about how we can break this encryption. When all we know is how long the prefix is. We know obviously how long our message is. We don't know how long the flag is, but we do know it's within a certain range. For instance, we know it has to be less than or equal to these number of bytes, which I think was 58, so it was 29 bytes. Does incrementing the message and observing the padding help you find the flag? I did think so, but I don't. I only think it'll let us know how like possible ranges. I don't think it actually tells us. All right. So what I'm going to do. Oops. Oh, no. So what I'm doing here is I'm copying and pasting okay, and I'm just going to mark this as X's. X basically means we don't know what this is. Alright. Can you see anything interesting about these encrypted bytes? So these are the this is the plain text, right? And these lines are the encrypted blocks. Does anyone notice anything? Overflow? What do you mean by overflow? The blocks repeat. Easy, you got it. And that makes sense, right? Because this is ECB mode, and I already told you, if you encrypt the same thing, right, you get the same output. So, can we use this to our advantage? It turns out we can. So what we're going to do is we're going... We know how to get to the second block, right? Because all we have to do is send 4 bytes, right, of this. Now, we could start guessing, right? We could put a guess in here, right? Fill 16 bytes and see if it equals this, right? But that's kind of what was it? Kind of reaching with that. So what can we do? Well, we know. So we send 4 bytes here, okay, and then we send 16 bytes, and then we send another 16 bytes. So we only want to send 4 plus 16 plus 16. Okay, so we're going to send 38 bytes. 38 bytes? Sorry, 36 bytes. 32 plus 4. Okay. So at this point, it's going to be a bit like this. Okay. So it's still going to be the same length, because obviously padding. But now we've got it like this. Okay, we can do this because we know how long the prefix is, so we know how to get to the end of the first block, and we know the block size. So how does this help us? Well, what if we don't send 16 bytes in the second block? What if we send 15 bytes? Well, if we send 15 bytes, then the first byte that was in this block is now here. Yeah? And we know this is the first byte of the flag. This isn't a hash, this is encryption. These are blocks. So this is a plain text block encrypts to that, this block encrypts to that, this block encrypts to that encrypts to that, blah blah blah. So by sending 4 bytes to get to the end of block 1, followed by 16 bytes to get to block 2, followed by 15 bytes, we've managed to pull in the first block of the 4th byte. Sorry, the first byte of the 4th block, which is the first byte of the flag. Does this help us in any way? Is anyone seeing how that could help us? I want to see if someone can get it. What same principle? Blind SQLI? I guess. Well, Branach knows it. Yeah, Guard's got it. So, we know that these blocks, right? We know the first 15 characters of this block. And we know the first 15 characters of this block. Right? We actually know all 16. But what if we change this character? Right? What if we change this to 0, 0? Now what happens if these are identical? If these are identical, what does that mean? So we resend the message and we get identical blocks back. What does that mean? It means this block and this block are the same. Which means whatever we put here is the first byte of the flag. So all we have to do to get the first byte of the flag is send 4 bytes of whatever we want, 15 bytes of whatever we want, 1 byte of our guess. So we'll start at 0, 0. Actually, to be fair, I did it by starting at the printable letters, so maybe we'll just start at A. Oh, trust me, better to say we have way more marble games to play. So we send 15 random bytes plus an A, a letter A. Okay? And then we send the same 15 random bytes here. And that's it. That's all we send. Which means if these two come back identical, we know this is an A. If these don't come back identical, we do the same thing, but we put a B here. And we iterate through every single letter until we get a match. And then we know the first byte of the flag. Now what do we do then? Well, it's very simple. We're just gonna take 1 byte out of our random bytes, and we'll put on another guess here, right? So let's say that this turned out to be 45, right? So our next guess is going to be 24, okay? So we're going to shift this back. We're going to put a 45 in there because we know that has to be 45. Now we've done this. Now we just repeat the same thing until we get every single letter of the first block. But then we run into an issue because we can no longer do that trick. because we've enumerated everything. We can't enumerate anymore. But what it turns out you can do then is just put another block in the way of random nonsense and start again from scratch. So let me do 1 1 0 0, and if we just put a random, so I'm gonna do R's for random, right? Obviously you can't send R's as hex, right? And then you get encryption back. We're gonna send a block of complete noise. Well, what does that mean when we do one less here? It means that we can now compare the 17th character of the string. Okay?
New
That
subscription
bit
received.
gets a bit confusing
Dispensing
because you're
gratitude.
sort of dealing with random.
Gratitude dispensed.
I can't pronounce your name. Xerx Rodadmin? Maybe? Thank you for the prime sub on a 2-month streak. Okay, we're going to add 2 more spins. Have I been tracking the spins good? I have. 0x Rod Admin gets 1. Let's just have a look at the code to solve this. This uses my favorite Python library, async.io. Async.io has a really neat open connection function. So basically to handle reading and writing from streams. Okay, so to go over this line by line, we have a flag, which we're going to keep track of. This is our unknown, right? We're just going to keep track of what we've solved. We've got a prefix length of 12, we knew that. We've got a block size of 16, we knew that. We're going to open a connection to the this thing, the server, right? Now, the first thing the server does is it sends 3 lines of text. So we're just going to read that and discard it. We don't care about that. If I go back here, you see 3 lines here? We're going to read 3 lines of text. We're then going to print the flag. No, wait a minute. Why are we doing that? Hang on. I don't know why that's there, actually. I don't think that should be there. Pretty sure this should be at the end, but whatever. Give me a sec. Pretty sure that's it. Okay, ignore that bit. Alright, so we're going to read the first 3 lines. We do not care about the first 3 lines, they're just noise. We're going to now enter a while true loop. We're setting dupes to false. All dupes is going to track is if there are duplicate blocks. Because all we care about is duplicate blocks. We're going to work out which block of the flag we're trying to find. You can ignore this. This basically just calculates whether we're on the first block or the second block or the third block of the flag. This is just going to calculate how much random noise we need to add. For each character in the printable characters, this is quite a neat way in Python to just get every single printable character. We're going to write... This is actually kind of funky. This is just going to write the character to the screen, and then later, if it's wrong, it deletes it. So it actually looks kind of cool. So you can ignore that. That's nothing. We're going to read 2 bytes in. What's the 2 bytes? The 2 bytes is this and the space. Right? Then we're going to make a guess. This looks confusing, but all we're doing here is taking the last 15 bytes of the flag, which at the start is nothing, and then we're appending our character guess, right? This is the crazy thing. I need to toggle software out. This is the message. So I had to write some instructions on what it is. But really, it's what we talked about here, just in code. So I'm going to send null bytes equal to the prefix length divided by the block size times the... Just ignore that. That basically will just print 12 bytes. not 12. It'll print 4, right? Yeah. So it's going to print 4 zeros. Then we're going to pad whatever our guess is with zeros. Okay, so it makes up a whole byte, a whole block. Okay, that's all that does. This bit is just the random stuff again, just in case we need random stuff. And this is this thing, right? So putting 15 or whatever we need bytes here. And that's it. And then we send a new line character to submit it, right? Because it's expecting a new line character. And then we write it, so we're going to send it. We are going to read the response. We're going to split the response into 32 because it's a 16 byte block, but obviously the bytes are represented in hex, so you double it. So we're going to split it into strings of 32 length. We're going to use a really simple way of checking whether there are duplicate strings. If there are, we set dupes to true. We add the character to our current flag, and then we break out of the current for loop. Okay? But if we don't break out of it, we delete whatever character we were guessing. We wait 0.1 seconds. We don't actually have to do this, but it looks cooler if we do. And then we iterate to the next character. All right? If we ever get to the point where there are no duplicates, we either know that we found the entire flag or that we fucked up. And that's all it's going to do. It's not SHA, no, it's encryption. So, okay, let's see this script in action. I'm just going to cancel it. We can just... You know what, I'm going to put it in a new window. So, Relate Oracle. Okay. Python 3 Oracle. Okay, so you see what it's doing here? Oh! It's worked out the first character of the flag as an H. It's worked out the second character of the flag as a T. There's a B. This next one takes a long time because the curly brace is all the way at the end. There's a curly brace. Oh, the next ones are quite easy because they're all at the start. 3, 4, 5. Y. The next one takes a while because I believe it's an underscore. There we go. My script might look cleaner because I literally spent an hour rewriting it, so now it actually works for any prefix size and any block size. Because I was like, if I run into this on a CTF again, I'm just going to reuse this code. So you can literally, you can give it any prefix length, any block size, and it'll do it. This is why this is so complicated. We're almost there. I think this is the last bit. So it's still iterating, remember? We still need to figure out. We're going to go through all the letters. But there are going to be no duplicates. And it prints the flag. So the only reason I put... So because this is running locally, that was about the speed it did it when I was connecting to the server. Because this is running locally, if I actually take out this sleep, it does it really stupidly quickly. But that doesn't look as cool. And just to show that you know, I didn't just program some funky code in, right? So here we go. I'm editing the challenge code now. All right. Let's do subscribe. Exclamation point, exclamation point, exclamation point. Okay. Let's now please subscribe. I'm just going to cancel it to run it again. Same code. What? Well, I've just found a bug. Oh no, hang on. Wait a minute. What did this do? Did I just fuck it
New
up?
subscription
Okay.
received. Dispensing gratitude. Gratitude dispensed.
How did I fuck this up? I think I need to make the flag longer. I'm just gonna put some random spaces at the end. I think my code doesn't work with too short a flag, maybe. What? Oh, I have to use... Yeah, no, you're right. Yeah, I'm an idiot. I have to use a byte string. My code's fine. Of course it is. Alright. Let's do it again. Clear this. There we go. Easy. Zero Kieran, thank you for the gift sub to Lost E. Welcome to the Empire. Lost E. Sorry. Zero Kieran gets a spin. Alright, is there any questions about that? Because honestly, that was...
New subscription received.
That took me
Dispensing
about
gratitude.
4 hours
Gratitude
to...
dispensed.
Kettle Bear, thank you so much for the subscription. Welcome to the Empire. The code did tell you. The flag technically told you. So hang on, we've got Kettle Bear. That's one. I haven't been keeping
New
track of all
subscription
these.
received. Dispensing gratitude. Gratitude
guys-
dispensed.
What is Agent OP? You are so generous. Thank you so much. Gifting 10 gift subs. Welcoming Stay Blazing, Saradator, Technique, Shirag Atani, Samoaf, I Am White Knife, War Inc., Insanities, Luxus, and Betilogaban to the community. Welcome to the Empire. Gar7, what are you doing?
New
Making it even
subscription
150.
Dispensing gratitude. Gratitude
I need to-
dispensed.
I need to keep track of all these numbers. Hang on. Alright, so we have Zero Kieran in there, we have Kettle Bear. Agent OP now has 10 spins. And Gar7 has another 7. I'm going to put yours at the end. I need to do some quick math here. That's 10, 11, 12, 13, 14, 24, 31. Alright, got 31 freaking spins. Thank you so much. You're too generous. You already donated like over $1,000 to my charity. Now you're just donating money to me. Any questions about any of that? I will try and explain it a bit better. Kettlebell, we probably won't get through all the spins on this stream. But I tell you what we will do. While people ask questions about anything to do with this Oracle attack, we will do a marble race. Zero, I can explain it again if you really want me to, or you can, watch the VOD. All right. Exclamation point play in chat if you want to enter the marble game. I hope that Bono's Tech is still here.
Dispensing gratitude.
Harry
Gratitude
Man,
dispensed.
thank you so much. Harry Man subscribing at tier 1. You subscribed for 2 months. Welcome back to the Empire, Harry Man. Taking us to 32. Nice power to do that. Alright, I'll start countdown. You've still got 60 seconds to enter. Just exclamation point play in chat. Bono's Tech is in. Perfect. That's the only person I cared about getting in. If you're too scared to ask a question, please don't be. Alright, this is a learning stream. I had to learn a lot of this. There was a blog post. I cannot remember who sent me the blog post. But again, like I said at the start of the stream, I didn't figure most of these out on my own. But effectively, we were working on this one. A few of us were individually. Someone, I don't remember the name, so I'm not going to say, but Someone linked to a blog post about this kind of attack and was like, this might be interesting, and I pretty much implemented it. And yeah, figured it all out. Okay, here we go. This looks interesting. This is kind of Japanese. I don't exactly know what's going on. Zoria bite. Ah, okay. We're kind of in the gutters. Oh, Bono's tech is in first, though. We'll see how long this lasts, but he's got a pretty good lead so far. Those look pretty even, so hopefully... Ooh. Ooh, Bono's tech lost a bit of speed there. He's still... Oh my goodness. Guxor almost overtook. Promaster now in second. He has some speed. Bono's tech though. Still. Did Promaster just go off the map? No, he's there. No, he did. F's in chat for Promaster. Bono's tech is no longer in first. Guxor has overtaken him. Gar7. F's in chat for DZE64. This is... Oh, okay, so we have to go back and down, I guess? Interesting. Well, looks like Gar7 has a bit of speed. Oh, F's in chat for Foxlord. And Perryman. Bye, Perryman. Oh, Gar7. No, he took the lead for a little bit there. And he's back in. Oh, he's not back in the lead. Oh, keeps freaking changing. Go. Guxor got stopped. But I think it might be enough. Here we go. Yep. Guxor first. Gar7 second, Tiberius third. We got a level 4 hype train going? That's insane. Thank you so much. Alright. So there's only 9 players. Great. Oh, let's watch the Hazy Cracker. You fell. Alright. Last place. Here we go. All the way down the staircase. Well done, Guxor. Is that your first? That's your first win, I think. Look at the amount of people who did not win. Alright. So we still got one marble race left. Let's do a few spins before we move on. There were no questions, which I do not believe for a second. But okay. If you understood that based on my rambling explanation, I'm sorry. I don't believe you. Alright, we got 32 spins to get through. We'll do a couple. And then we'll move on to the web stuff. That was the last crypto one I solved. Add a category. Jean, if you're still here, we need a category. Okay, good. I'm glad. I can understand it in my head. I don't know if I'm explaining it very well. The code is not publicly available, but I'll put it on my GitHub at some point. Actually, we reached 150, so we're going to do a Try Hack Me giveaway at some point. Okay, we'll do a Try Hack Me giveaway the next marble race, alright? I'm just going to make a reminder. Try Hack Me giveaway. Okay, Jean, if you're still in, we need a, add a category. Chat can choose. Okay, chat, come up with some options. We'll do a poll. So we'll do Jean's last spin here. More cat time. Jean, who do you want? We've got Raven again, Terry, or Arya. There was the box on PG practice. That's awesome. I wonder if my code works against it. Okay, so we got. So like Hack the Box VIP. Okay. For a month. So I guess 1 month Hack the Box VIP voucher. Okay. Stream Raiders time. Well, what is? Oh right. I thought you meant as a category. I'm like, that makes no sense. Cat Itsy Shadow. Oh, VIP in chat. Okay. I can just award VIP to someone, I guess. VIP to. I guess VIP to the spinner. Anyone else? Oh, I can choose the cat. Alright. I'll go fetch Arya because Tiri's a bit fragile right now. Okay. I'll be right back. I want at least a couple more options, then we'll have a poll. So we're adding a category, chat. Alright. That's the last of Sean's one. Alright, be right back. Upset Arya. Here she is. Hi, baby. Say hello. Yeah, she's a sweetie. My mirror shows the other side of me. All these ones and zeros, nothing in between. But there's so much more to me than eyes can see. Alright, we'll let you go. Than eyes can see. I'm not binary. Come on. Just sitting on my lap right now. Go. Alright. Add a category asking. Well, I guess we didn't have any other suggestions. Oh, double the amount of worst spins. We're not doing that. That would be insane. Imagine if you got 2 times that. Stream Raiders, yes, we'll do Stream Raiders. Alright, so I'll just add The VIP one. Yeah. All right. Done. A timeout user for 5 minutes. We could do that, but you missed the you missed the go. We'll have to wait until the next spin. We came so close to Zap Gang for the rest of the stream. I think I need to use the brush again. There we go. Much better. Okay, open the captain chest. Fraggle 780, well done. Yeah, this is that gang for rest of stream. Okay. Let's do one more spin. Why did I put it on my face? We don't want to see that. There. We're doing one more spin. Oh, remove a category. Well. Do you know whose spin that was? That was my spin. So I get to remove a category. Which category should I remove? Ooh. You know what? We'll take reset the box off. Boom, it's gone. Someone will have to add it back. Remove a category is technically available. Although I think it probably shouldn't be. Okay, let's move on. I've got one more spin. They're out for this stream, yeah. Reset the box and kill terminal are out for this stream just because that would just really annoy me. But I've already been annoyed this week. Okay. So let's move on to BlinkerFluids. So hopefully I can just do build Docker. We don't need this anymore. We got a local host 1337. Should I? Localhost 1337 hopefully works. Is it working in the terminal? It's not. Okay. Why? This was working yesterday. Oh, hang on. I think I restarted Docker last time, I think, and that worked. That works. For some reason, Docker is a bitch. Alright, there we go. Okay, so again, like all of these, we had the code. I'm going to delete all this crap. Okay. So again, I have put the flag in here. This was the real flag. But obviously we didn't have this in the CTF. We have a Docker file which basically just tells us the flag is at /flag.txt. The application is in /app. All these challenge files were in /app, I think. Okay, so we can start by looking at the database. So It's using SQLite. So this is just the setup, I think. Yeah. Okay. The package.json is always useful. In this case, it was especially useful because this comes into play later. But if we look at the app, what you can do is you can create a new invoice. You can give it some text. So, I mean, let's just do please subscribe. Save. And then it would create this invoice ID, and then you could go to this PDF export, and it would export it. Okay. So crucially, you could do formatting, right? So if we did, what's a good format? Italics. Can't spell italics. Do the PDF export. We get italics. Right. So what does the request look like? The request looks like this. So the markdown content. One thing which led us down a complete rabbit hole for like 2 hours was the fact that you could actually, I'm pretty sure you could put, yeah, I do want to do strike throughs. You could do strike throughs here. And it would work. So we spent a long time trying to get SSRF within the PDF. And it turned out that wasn't it at all. Is this an iframe one? No, it wasn't in here. Joel, thank you for being here. Was a good platform with models for sec reports? You mean like pen testing reports? And what do you mean by platform? You like a reporting tool? Dradis. That's what I use at work. If you want example reports, my friend has a if you want example reports, Leos is GitHub reports. Yeah. My friend Julio has this, which is basically his collection of publicly available pen test reports. There you go. He definitely updates it. Look, like 6 months ago. I mean, pen test reports don't generally get released that often, so 6 months is. He's been doing this for years. This 6 years, I think. So definitely a really good resource. Okay. So back to this. So again, we spent quite a while trying to get something to work. I think we could get JavaScript to work, but ultimately it didn't lead us anywhere. So then we started looking in the package, and we noticed this MD to PDF 4.1.0. So obviously we are converting Markdown to PDF, so that's probably important. So if you do go to Google, and we're just going to Google MD to PDF 4.1.0. There's this lovely sneak link, the vulnerabilities, remote code execution. Interesting, right? We found this pretty quickly, and it did not work. And this is where I have to say I hate whoever wrote this. Because all they seem to have done is copy and pasted the proof of concept from some website into their whatever tool they use at the back end, and then submitted the article and didn't check it. Because do you see this N here? And do you see this N here? Those aren't supposed to be N's. Those are supposed to be backslash N's. And it turns out if you don't make them backslash N's, this code just doesn't do shit. We spent hours. We spent hours trying to figure out why this wasn't working. Because I thought, oh, JSN, maybe JSON. I didn't know why this N was here, but I thought, that's weird. Yeah. So. Obviously, this doesn't... I mean, you can't really do this. There's a few ways to exploit this. Obviously, it doesn't return any of the content, right? And it won't return any of the content in the PDF either. So there's a few things you can do. We know that we know the directory where this is. This is /app. And I think it's just /app, actually. So it's /app/static. So static directory pretty much just serves up static files. So if we can get a file in there, we can copy the flag.txt to here, we can access it. It won't go through any kind of like processing. So obviously, what we want to do is copy this JSON object. Yeah, we did out of band. I'll show that as well. So if we go back to this, and we're going to paste this in here. And obviously, we need to backslash the stupid N. We also need to backslash these because we're in a JSON object already. And also these, and this, and this backslash N again. So what we can do is we can do copy /flag.txt to /app/static static/flag.txt. Okay. Invoice save. Now it turns out the PDF is generated automatically. It doesn't generate when you click it. So if we go to, let's open a new tab and go to static flag.txt. The flag's there already. Okay. But suppose we didn't have write access. You could also do this cool trick with Tabulator, which is the burp collaborator. You create a new payload. We're going to go back here and we're going to use... The curl doesn't exist on these machines for some reason, but wget does. We're just going to wget it. We're going to do... so I'll surround this by single quotes. And we'll do flag equals... and then, because this is executing in bash, we can do the backticks, which may execute this. base64-w0/flag.txt. So it's going to convert /flag to base64 and just add it on the end here. So we send that, that should work. And then if we go back to Tabulator and click poll now, there we go. We get a DNS hit. That didn't work, so I presume we don't need these. Send it again. Poll now again. That's better. Alright, so we didn't actually need the little single quotes. And then if you just go to HackTheBox and paste this and decode base64, there you go. Any questions about that? And Bono's Tech is in chat with some free burp collaborator alternatives. Thank you so much. Okay. If there are no questions, we will do some more spins while people think about questions. I'm just going to count the spins we have left. 7, 8, 9, 10, 11, 1, 8. Okay, we are at 20. This is my second spin. This is my only remaining spin. Rigged, eh? I get to remove another category. Hmm. Dude, kill my terminal. Hmm. You know what? Let's remove change stream title. There we go. I'm gonna keep track of all the removed freaking ones. Okay, so that's my goes out though. Go back to 28. We'll do a couple more, and then we'll do the Marvel giveaway. Should be for a Try Hack Me 2-month voucher. Oh, there we go. That was Ryan D. Everyone, please subscribe to my YouTube. Exclamation point YouTube will get you the link. The wheel says you have to do it, so you have to do it. All right, one more. Now we're on Gar 7 spins. All right. This is gonna be fun for the marble race. Hack without glasses. Oh, hang on a minute. Okay. Can't see a damn thing. All right. Marbles. There's the marble button. There we go. Okay, random endurance test? Sure. Okay, so again, this is for a Try Hack Me 2-month voucher. Exclamation point play. If you win and you don't want the voucher, you get to decide what happens to the voucher. Okay, you can either give it to someone you know in real life, or you can give it to someone in chat, or you can even give it to somebody who's not in chat. Okay? And this is because Gar7 got us to 150 subs. Thank you so much, Gar. Okay, so we'll do 60-second countdown again. Unfortunately it's random spawn places. I don't know why, but it's just the luck of the draw. Can't type due to spam. Oh, hang on. I thought I disabled that. Hang on, let me can I cancel it? No, I can't. Here we go. I can't even get back to my chat now, but I have figured out apparently how to get to the stream menu. I forgot to put a timer on. I'll put a timer on now for 5 minutes. Where are you going, Magic? Oh, you're first. For some reason I thought you were still up top. There we go. A little bit of slow down there. Oh, looks like Loka is in first now. Halloran taking the lead. These look pretty equal. So I think Halloran should maintain his lead here. Skipped all of that section. Skip that bit, that's good. Will he make it past this? No. Ooh. The slowdown and just a guy now. Just a guy wins. Didn't you say you'd take the voucher? That's Alright. I do need to we'll wait for everybody else. There we go. Wins in at 69. Last but not least. Alright, well done, Just a Guy. Okay, so now I need to figure out how to get out of this menu that I just accidentally found myself in. Just refresh chat, is that? Okay, refresh chat works. Alright. But I can't put the glasses back on, Christy. I have 1 minute 51. Alright, I need to go up here. Okay, what do I just win? Refresher than your caffeine. All right, Just a Guy. Yeah. What do you want to do with the coupon? I can't put the chat. The wheel spoke. Okay. If you're bound by the wheel, I'm bound by the wheel. All right. I technically made the rules, but I'm gonna follow them. You're taking the coupon. All right. I'm gonna make a note. Voucher to... I'm just going to make a note of your name because there's probably a few Just a Guys. I'm doing this without glasses, so if you don't get it, you're screwed. 1, 2, 3, 4, 5, 6, 7. Alright. Just a Guy. There we go. Nice. Well done. Well done, my friend. Make a bigger note. It's not the note that's the problem. It's me reading chat. Everything's a bit blurry right now. We got 28 seconds left. Alright. Let's we'll do one more spin. We'll do another spin from Gar. What? Just screwed me. We had 9 seconds left. Oh, another 5 minutes. Alright. Okay. Were there any questions about this box? This was one of the very easy boxes. So, nobody has any questions. We shall move on. What was the next one I had on my list? Amidst Us. Okay, and again we can just build Docker. I think it's building. I see an IP address, kind of. Alright, here we go. Refresh. So Amidst Us was Among Us themed. Cryptos was pretty easy. I wish I could show Cryptos, but for some reason they didn't let me download the code. Same with Red Island. Red Island's solution was actually pretty fun. We completely cheesed it. But the solution was relatively similar to how we do it. Okay, so I'm gonna upload an image. This, for those of you who don't know, this is basically an image upload. It doesn't look like it, but whatever. You upload your image, and then you can click this, and then you can choose colors. So if you want it to be blue, you can do that, and then it like puts a little filter back. How did we cheese it? So apparently the way you were supposed to do it is realize that there's a sandbox escape in Redis, which you could interact with through Gopher. There's an SSRF that allows you to interact with Redis. Not this, by the way. This is completely separate. We didn't find that one. Oh, it was Lua. I was playing with Lua for ages. All right. So what I figured out was, because we could save the database, and because we could save it anywhere, if we booted the box but didn't ever actually hit the website, but instead just used the APIs, we could interact with the database, and we could save over the registration template file, which was using Ginger, I think. And then we could just put RCE in there, and so we got a full shell. So basically, what we did was we saved over the template, and then when you visited it, it spawned our shell, and then we could interact with Redis properly. Spent ages searching for the flag, and then eventually figured, oh, actually, we can break out of Redis using an exploit. And then, yeah. It might have been nunchucks. There were so many. To be honest with you, I cheesed the other box like that. What was it? I cheesed Acnologia Portal the exact same way. Yeah. No, Acnologia wasn't. I actually know how to do Acnologia, kind of. Oh, I know another cheese method, which, to be honest, I think is much better than the actual method, but whatever. Okay, so I got a minute left on the glasses. So this puts a blue sort of filter over my image. Yeah, the symlink, exactly. Let's see what it's doing. Well, let's go to this. It's posting to API AlphaFi. The image is converted to base 64, so this is a huge image. Pretty, this actually. And then there's background, which passes a list of 255, 255, 255, which then, I guess, it runs some code at the back end and adjusts the image and makes it blue. So again, if you look at the code, go to Amidst Us, close this, and we go to requirements. This was pretty easy to spot. There was this pillow. So this is a Python app, a Flask app. There's pillow 840. So if we go to Google and do pillow 840 exploit. There we go. Oh, I can put my glasses on. There we go. Arbitrary code execution in all versions of Pillow, less than 9. But specifically in this PIL imagemath.eval, I wonder if that's in the code. Turns out if you track down the code and go to util, here's the make alpha thing, gets the base64 image, gets the image bands. That's the thing we were just, it's this thing. And then it puts it into imagemath.eval. So the image bands, I think, were... Oh, no, so the color is this. The color of data is here. So it's in the color object. So we can put it into any of the colors we can inject into an eval, right? So yeah. And it turns out it allows evaluation of arbitrary expressions, such as ones that use the Python exec method. So that's fun, right? So pretty much, if you convert this to, I think you have to do a string. Yeah, convert this to a string, and then we do exec. Oops. And then we can do this. We have to obviously put it in quotes. Let's import time. Time.sleep5. So we'll just verify that this works. And we wait. It does. That was pretty much 5 seconds. So we have Python code we can execute here. So we can pretty much do the exact same thing we did last time. We could copy it into static if we wanted to. Or we could use this trick, the tabulator again, which we will do. So if we can import instead of OS, and then do os.system, and then we do need single quotes here, wget HTB, we'll do, we'll do stream ranges in a minute. And then if we just do the same thing, base64-w0, so it's a whole string, flag.txt, send that, fresh tabulator, there you go, back into HackTheBox. Any questions on that? Let's do stream raiders. Yeah, so honestly, that one didn't take too long to find. Because it's just, it was so simple. The payload was fine. We haven't talked about the money one. The money one is going to be last. The money one is hilarious because we accidentally solved it the hard way, and then realized that was actually the way you were supposed to solve the second. So it was even better. Okay. Open the captain's chest. Grant rewards. But on Christie. This hard battle. I'm going to bring out my archer guy. Okay. We'll do a few more spins to get through some of them. So we've got, I think Gar has 3 left. God, why'd you keep doing this to me? That's three times in a row. Ah, oh, alright. Gar's rigged it. Alright, 5-minute timer. Alright, we'll just get rid of Gar's spins. He's got 2 more. Okay, Gar. Choose a category to remove. We're removing so many categories. Hopefully someone gets an add category. MNAP-CB. How about you? My vision is not too bad. I can still read comments. They're just a little bit blurry, and honestly, I'm not going to strain my eyes a little bit. It's only for 5 minutes at a time. I'm also close. I'm close-sighted, so if I go in here, everything's fine. But obviously, then you can't see. All right, Gar. I'm gonna do your last spin while you figure out what to remove. Otherwise, I'm gonna let chat decide. But at least all lurkers have to follow. So, chat, if you are lurking, if you do not already follow my Twitch and yet you are watching, you gotta click that follow button right now. There we go. I see you, Damnionos. Can you talk through a solution for Kryptos support? Since you can't show it. Yes. Let me get the Discord up because I posted them all in our Discord server. Gotta figure out how many. 22 left. Edgewalker, are you just spamming? I think I just need to pick you. Okay. Well, yeah, please don't do it. All right. Let me see if I can get the Kryptos one. Okay. Okay. So for Kryptos, you could submit a ticket. There was an admin user who would look at the tickets every now and then. So if you submitted some HTML code, it would render. So you could basically just use JavaScript to extract their cookie, and then you get a moderator cookie. And then when you're in the back end of the application, there was a settings page where you could change your password. So actually, no, you weren't an admin, sorry, you were a moderator. So you could change your password, but the request had the user ID. So it's basically a post to change password, user ID equals 2. And if you then just change that to 1, you change the admin user's password, and then you just log in and get the flag. So it was a combination of an XSS attack to get the cookie, and then an IDOR vulnerability. Okay, Compendium has redeemed Raven. Okay, I'll go get Raven. I'm gonna wait for the timer so I don't, walk down the stairs with my glasses missing. All right, we'll do one more spin. I didn't see anything from Gar. He may have just left. So chat, I need to come up with a one of these to remove until someone adds them back. We'll do one more spin for Damionos. Is your spin, my friend? Look at that. You won a marble race. Fantastic. Do a random track. Switch to marbles. So I'll go get Raven because the timer just went off. Please stop. Okay, I will go get Raven. And you can all do !play. There's no giveaway for this, unfortunately, but, have some fun with it. Alright, I'll be back with Raven. know what you're going to say. This isn't Raven, this is Tiri. I could not find Raven. She has gone hiding somewhere. But here is the other kitty. This is the eldest. Here we go. She's also the sheddiest. My shirt is going to be completely covered. All right. Look at my freaking shirt. It's covered. All right. Good. Sticky roller time. Exactly. Genius idea. Okay. So, we'll go back to marbles. Okay. Do we have one to remove yet? Just a guy really digging the wireless headphones. Yeah, these are the Sony, whatever they're called, WXH or something. They're really good. Okay, so yeah, something like SM4. They just released the 5th version of them, I think. I bought these last year, so they hold a charge really well. Like they can go for like, I think 36 hours. They're really useful. Yeah, I haven't like ever timed them, I guess, but that's what they claim, and I do not charge them that often. So I pretty much spend my day hacking and listening to music. So I charge them, you know, once every 3 or 4 days, I think. Oreo bites just zooming ahead. Oh. Just the guy's in the lead though again. Is he gonna keep it? So far so good. Oh no! F in chat. Oh, a few people have fallen off. Christy, F's in chat for Christy. Exorcism just helped Hat and Dog along. This is interesting. You have to get into one of these holes at the bottom, I think. There we go. Made it. So I think. No, okay. Duxor is now in the lead. Still in the lead. Is he gonna get past this? This is insane. Oh, hang on. Hat and Dog just got through it first try. And then, oh, Loka. You came so close to landing that jump. There we go. Hat and Dog, well done. I think Hat and Dog said he'd do a 24-hour stream, right? If he won. I look forward to that, my friend. I'm gonna have to give you a follow. Alright, let's see. Let's follow Kettle Bear. Always following the last place. Actually, might not be last place after this. Really depends. Let's see. Alright, who's still in? Real Eagle Slam made it out. We got Kettle Bear, Kevin Batdorf, and Gagor. And it looks like everybody but Kettle Bear is making it out. We got 35 seconds, Kettle Bear. Will you make it out this time? Nope. It's still technically doable. Oh, this looks good. You made it. Alright, well done, Hamdog. It was your first win as well, I think, right? Okay. So, moving swiftly on. Okay. Intergalactic Post now. Okay. Build Docker container. Alright, this is an extremely simple web app. You basically just subscribe. And you get a message saying email subscribed successfully. That's pretty much it. That's all the app does. Post to subscribe, email, and then it redirects you to this. So again, probably need to look at the code. If we go down to Intergalactic Post here, there's the challenge. So router doesn't really give us anything. This is a PHP app. So we see that the subscribe, so post subscribe goes to a subs controller. So if we go to controllers and go to subs controller, we see that, alright, now go. It goes to sub controller store, so it goes to the store function. Alright, so here's the store function. Just a guy. Okay, well, 3 a.m. Thank you so much for staying up. Hope you enjoyed the stream. What is PG in the side? But that's Proving Grounds, which we don't play that often. So the store function takes the email out of the post request. So it takes this thing, right? And it looks like it validates it. So it basically filters if it's not an email. So we can probably test for that. We can go like, let's put an apostrophe on the end. Please submit a valid email address. Okay. So that's interesting. But if it's fine, if it passes this filter check, it then builds a new subscriber model. Okay, so let's open subscriber model. So actually going to open subs control completely, subscriber model. Okay. It generates a new subscriber model, and then it uses the subscribe method with the email. So use the subscribe method of the subscriber model, and then it redirects. So let's go into subscriber model. This is basically, it's a good technique for pretty much, if you have a web app and just tracking it through. This is white box. Yeah, this would be white box. So you're pretty much, you've enumerated all the things the app can do, and you're just following through. So we found the subscribe, we visited the subs controller, we read store, that pointed us to subscriber model. We're now in this function, subscribe. This gets an email address using the get subscriber IP function, this function here. And it looks like from this function, if it detects the HTTP header X forwarded for, it uses that. So this is pretty dangerous. You shouldn't ever take that as the first IP address, honestly, unless you're thinking that you're dealing with a proxy. But we can control this parameter. And it doesn't look like at this stage it's getting checked. So we can put anything we want in this field. Okay. But it then goes to the database, subscribe user using the IP address and email. So we now need to figure out where this subscribe user is. It's probably in this database.php file. And yes, it is. So this function subscribe user takes this IP address, which we can control, and this email, which we can also control, but it has validation. So we can only give valid emails. And then it inserts into subscribers IP address email, and look at that. It just passes in the value. So immediately we are in SQL injection territory. Okay? And we're in SQLite 3 database. We're in an insert query, so it's kind of tricky. But you can technically enumerate. So if we... Really, the best way to do this is to go to payloads, all the things. And then SQLite injection. There it is. It has its own dedicated page. So this tells us the comments. We don't want to do SQLite quite yet. This tells us the comments, tells us the version, how to extract table names, how to extract column names. But really, we should try. Let's try and trigger this, because this is probably going to be blind. So even if we add our X forwarded for header, let's say 127001, and let's just put an apostrophe there. Yeah. So we get the same response back. Like we could try. Actually, we know it's not going to be a double quote. Because we have the code. So our apostrophe should have broken something there, and it didn't. All right. So we can inject, but it's completely blind. Luckily, there is the email is filtered. If you look at this, we can't enter. Hang on, what? Oh, I put that. Okay. Well, either way, we get email subscribed successfully, whether we did that either. So it's the same thing. Thanks for pointing that out. But we can use this to try and generate a time lag. We use this. And so we just have to replace this sleep time with a value. Now, in SQLite, I believe you can concatenate using these. So what we want to do is we want to concatenate. So we're breaking out of the SQL. We're then using concatenation, and then we're breaking back in. So this should be a valid query if we put a sleep time here. So we put a 5. If this works, this should sleep for 5 seconds. And it looks like it is working. That slept for 10 seconds, so that's, I guess, slightly odd, but okay. The fact is it slept, so we're good. So you could, at this stage, start enumerating the database. And to be quite honest with you, we did that, and we did it manually, and it took quite a long time. But I did this on a stream recently. I did it actually on a stream on Wednesday, enumeration, like that blind. And I can tell you, I'll ruin it, I guess. There wasn't anything else. There was no other databases. There were no other tables. It was just this subscribers table, and it only had the values in that we expected. There wasn't a flag in the database. Yes, I am going to DEF CON this year. So, if getting into the database, if extracting information in the database isn't the way in, what is? you go back to this article, there's two things down here. Remote command execution using SQLite. There's two of them. Now, we aren't running... Oh, this seems Windows specific. Maybe it's not, but this I don't know. I didn't try this, but maybe if this hadn't worked, we could have. However, this did work. So what happened was SQLite had stacked queries enabled. What that means is, so instead of doing this, we could have just ended the SQL statement another way, right? So remember, we're still injecting into this values thing, so we need to effectively supply it with the email address and then a closing parenthesis, all right, to make this valid. It doesn't matter that there's nothing in here, right? And then if we try doing a sleep and then just put something on the end like that, it doesn't work, but I think if you do select, I think that works. Yeah. So now if you do the select, it's selecting whatever this is, but that's just a 5-second delay. So we know now we can do multiple queries. And so all we need to do is copy this. And we'll put it in here. We don't care about the delay anymore. We obviously need them all to be on one line though, because it's a header. Now, we need to change a few things because we know from the code that the database, in the Docker file, everything's in /dub. Okay? Isn't email getting... Yeah, the email's fine. But this is encoded. This is an @ symbol encoded. Alright, so we know we're not in /var dub. We're in just dub. So that's fine. And then we can just do, yeah, system get command. Let's see if that works. Okay, it says successful, but again, it might not have been. If we go here and then go to, what was it, lol.php. Look at that. We have a database. But more importantly, if we do cmd equals id, we have code execution. And then it's just a matter of having... So I think in this one there was a random, if I remember correctly. Yeah, there was a random flag, but you can just do cat/flag asterisk, and it'll cat everything that's called, that starts with flag. There we go. Wipe. Oh, okay. Yeah, so we need to do that because this isn't actually getting passed. We're actually exiting out of this. We're injecting... We're injecting into this bit of the query. So everything afterwards, we can't change. All right? So we can't add this. We can't even get back to this. So if we want to execute our statements, we have to break out of this, end it manually, and then execute our statements. All right. Let me explain it a bit better. So let's say that this is our email @email.com, right? And we can inject in here. So if we just did like an injection like that, and then something like that, this won't work because it's invalid, because it's expecting two values. So we already have to do something like that. But now you see this query is just on its own here, right? It's nonsense. We can put anything here. We could do selects. We could execute anything here, blah, blah, blah. But you're always still going to get this at the end. So to deal with this, we do our comment. Okay. Yeah, exactly. I commented out. Any questions about that one? Okay, we will do some more wheel spins. I still haven't seen an ad. Nobody came up with a remove, so I guess we're not removing anything. Okay, this is for Rod Admin. Well, there you go, Rod Admin. You get to add a category. Now, we've removed reset box and changed stream title. If you want to add those back, you can. One of them, I guess. Or you could come up with your very own. And again, within reason. Show the remove. We've got change stream title and reset box. These are only removed for this stream. These aren't actually properly removed. Same with this one. These will be back. These will be back on Monday. Well, got my terminal? No, I'm saying this is back. Just ignore this. It's just disabled, it's not removed. The other ones are actually removed. Alright, we'll do 0, Kieran. A spin for you. Oh. Thank you, 0, Kieran. Everybody subscribe to my YouTube channel. Give a cool pro tip. Okay. It's going to be interesting. Set it to a 5. Alright. 0, Kieran, thank you very much for the everyone getting everyone to subscribe to my YouTube channel. Alright, we'll do Stream Raiders. Try and check on how many solutions we have left. Just did Intergalactic Post. So next we have Acnologia Portal, then Spiky Tamagotchi, and then Genesis Wallet and Genesis Wallet's Revenge. So we got 4 left. Oh, Oreo Bite redeemed a Rubik's Cube solve. We'll do that next. If you're still there, Oreo Bite, I do apologize. I missed that. Too many things going on in chat. This is a freaking long one. Alright, victory. On Compendium 66, Christie and Ghosts are spooky. Start battle. There we go. Okay, we'll go back to this. Alright, I'm gonna look away and scramble. You out for what you say to me. Look at every single need. If you got what I need, then oh, I'll take you on like a big deal. Eggs you can unseal. Key in ignition. Just keep me full like Hopefully everyone agrees that is rather pleasantly scrambled. Okay, and now Soul. Stream, show. Okay. There we go. Nice and solved. Alright, redeemed. 29 minutes late, but we're still redeemed. Okay. Moving on. Acnologia Portal. So this is the one I think I know how to do it properly. It wasn't working for me. I tried last night. See you, Bodosec. Thank you for stopping by. Okay. So, let's boot it up. Where back in the portal, build Docker. So this one was interesting. We go to main. We see there is / and /API. There's also a bot. So the bot logs in as admin and goes to the review page. The database, config file, and that. The util is interesting. So there's an is_admin function, obviously, which checks if you're admin. Looks like you can't bypass that because you need to actually come from localhost. There's also this extract firmware, which is interesting. So this takes a file, it gets the temp directory, and then it creates a path, which is basically /temp/filename, and then it saves it to that path. Then if the tar file, it checks whether the file at the path is a tar file, which tells us we need to have this tar file. And if it is, it opens it and extracts all into temp. And then it goes ground for everything in the tar file. It takes the name, checks if it's a regular file, and if it is, it moves it. And it will move it to whatever the file name is. So this is an interesting one because this struck us as odd the first time we read it, but effectively what this means is if you can somehow manipulate the file names inside of a tar to include absolute paths, then you can write that file to anywhere on disk, right? Because it's basically just going to move it from the temp directory where it was written originally to wherever it says the file name. Now, luckily, you don't even have to manipulate this because you can do this in tar by default. So to show you that, did I do anything in slash yet? I'm gonna remove slash add. Okay. I created a tar directory for this. But if you do tar C for compress, Z for GZ, I don't even think you need GZ, but we're going to use it. If you do a capital P preserves the absolute file path. So now if we do test.tgz and we say, like, let's just say etc password, right? So now we have this tar. Oh, sorry, this test.tgz. We can actually open this in Vim. Vim actually parses these pretty well. And we see that there's etc password right in there. And it's slash etc password. Okay? So to compare, right? If we'd done this and we do like test2 and we just done no capital P and then we vim test2, now the slash has gone. You see that? So that makes it effectively a file in whichever directory it's already in when it's extracted. So the other thing to note, and when there's a bot in these, it usually means you're going to have to interact with the bot somehow. Now it goes to the review page, so let's check that out. So if we go into, I think we go to Blueprints routes. So this is where all the routes are. We go down to review. We see it gets reports, and then it renders the template review.html, and it passes the reports object here, or the reports list, as this variable reports. So if we go into the templates file, go into review, and we see we get reported by report module ID, report issue passed to safe. So what does this mean? So we're in, let's just check the is there a I think this might just be Flask. So if we do Flask pipe safe, oops, I guess render template safe is another one. I'm building an admin for Flask in SQL Academy, and I want to pass the HTML for different inputs to my view. The templating framework seems to escape the HTML automatically. How can I disable that? You can turn off auto escaping by doing pipe safe. So, in this review page, the report issue text, even though we're piping it to safe, this effectively means, oh, don't bother escaping this HTML code. So we have an XSS. If we can write to an issue, we can pass XSS. Now, why might that be useful? Well, like I said, there's an admin user visiting the review page. Let's see where this extract firmware ends up. We can do that by searching in this folder. We'll search for extract firmware. And we've already been in util, so the only other place it is in the routes file. There's no SSTI because you can't escape out of these. We're inside one of these. You can't escape out of them. Okay. you would only be able to escape out if they were doing something stupid, like having like an eval here and evaluating this, or like echoing this into the file. But this is perfectly fine. All right, this is actually how you're supposed to do it, right? That's all fine. But if there's another way of doing it where you can pretty much just code it in, where you actually echo it out, and if you're doing that, then yeah, you can break out of it. But this isn't SSDF. So let's go to the routes file. Extract firmware is in there. Oops, sorry, it's on line 105. So there's this /firmware/upload. Okay. So that's interesting. /firmware/report. So firmware upload requires an admin, right? It's also, we scroll up to the top. Something I missed the first time around. This defines two URLs, effectively two paths. The web path, which is at /web, and sorry, not the web path. The web path, which is just web, and the API, which is API. And effectively, what this means is when we're using the API route, you're going to stick API in front of it. Okay? So let's log in. Let's just visit the application and see what we can actually do. It's going to load. Maybe I do Control Shift. Oh, there we go. Okay, so we have to create an account. Okay. Let's see what happened there. So you can see there's the API, post API login. Everything else is just /. So it looks like there's no firmware, which is odd. There should be. Hang on, this is bugged, I think. There should be a bunch of firmware here. Let me try to reload. There it is. Okay, for some reason this is glitching out of it. So we can report a bug. And if we go to this page, scroll down to where the form is. So looks like it's all using JavaScript, so we need to check the main.js. Report box, report function. Right. So the report function is going to send this our form data to API firmware report. Okay. So we go back in here. API firmware report is here, and like we suspect, it takes module ID issue and then creates a new report. So we can enter our XSS here. So the first thing we do is we validate this. Create a new tabulator payload. And we're just going to go back here, and then we're going to say, okay, image source equals this. So if we can inject images, we already know we can inject scripts. I guess technically we could do this as well. We could try to go for a twofer and do new image.src equals and then do script, and then we'll generate a new payload for that one. Yeah. Okay. And HTTP there. So if we get a hit on EK27, we know that this worked. If we get a hit on IF1B, we know that this worked. So we can report. The other stupid thing about this box is after you submit the report, it completely destroys the database, including your session and including all like users and everything. It's kind of annoying. Okay. Well, it looked like we got 2 requests, both of them to the ones we want. Jay Beers, thank you so much for the raid. How was your stream, my friend? The Liga. You're back to ya. We are walking through. I know the name of the stream is something weird right now. Chat won a spin. Here's the sticky roller. But yeah, we are doing HackTheBox CTF solutions for the previous CTF, which was this week technically. Okay, so we just got hit, so we know that we can execute scripts, which means we can execute an XSS attack. Now,
received. Dispensing gratitude.
GoPro
Gratitude
Slow-Yo
dispensed.
has subscribed for 9 months on a 9-month streak. Thank you so much. You get a spin, my friend. You're currently in 20th place. So it might be a while, but... Okay. So one thing that obviously springs to mind when you have an XSS attack is what if we just steal the cookies, right? And I did try that, and I can report that doesn't work. And the reason it doesn't work is when you... I'm trying to find the actual thing. Where's the login? It might not even be here. There's a config thing. I think it sets the it sets the flag up so they're not accessible by cookies. I can't exactly remember where that is. It might actually be here. No. There is a place where it does it. I just cannot remember where. It may even be automatic. Either way, the cookies do not have the so they have the HTTP only object. You can actually view that here when we get a cookie. I guess here. It's set with the HTTP only flag, which means JavaScript cannot grab this cookie. It is impossible. So we cannot do an XSS where we steal the cookies. However, we can, because we know that this, where is it? Firmware upload function exists, and but it's protected. It requires an admin to work, right? So only admins can get to this. If we tried to get to this, it would give us a 403 or something. We can force the admin to upload our file. Okay. And I have the code for that. Over here. And that's the code. You base64 encode whatever file you want here. You shove it in that. Then this converts it to a blob. And then it's a simple matter of creating a form data object, appending the blob as the file parameter, give it a name, and then just doing this, right? Requesting the API firmware upload specifically at localhost because that is where they are visiting if you go to the blob. They're going to localhost 1337. Okay? So now the question becomes, what do we actually send, right? Well, I'm pretty sure the answer is based on the actual cookies themselves. The cookies that they have are serialized objects that are stored on the file system. So these aren't serialized. This is a reference to the cookie. But if you MD5 hash this, and then look in the Flask session directory on the server when you authenticate, there will be a file named after the MD5 hash of your session cookie, and in that there is a pickled object, basically a serialized object. Now, I tried for like an hour last night to get that working, and it just wouldn't work. So I'm waiting around for some more write-ups, because honestly, it just wasn't. I don't know exactly why, but it just wasn't working. However, this one you can solve via another method, unintentional. So remember going back here, when we zipped up something using -P, it would preserve the leading /, right? Now, we know where the flag is. The flag is on it's on /flag. We also know where the app is. It's in /app, and then it's in application, and there's a static directory. So what we can do is we can do make directory -p/app/application static. That's going to create all 3 directories there. I need to sudo it. And then if we create a flag.txt file. So if I just sudo touch /flag.txt, and then I do ln, so I do a link to /flag.txt, and I put it in /application static flag.txt. I'll need to sudo it. Okay. So now in /app application static, there's a file called flag.txt, which is just a link to /flag.txt. Okay. Let's remove these tests. Now, if we tar czf ef, just test.tdz /app application static flag.txt. Okay, we've in this. There's the whole thing. It technically goes to nothing, but it's still a link. Yeah, I'm kicking myself. Okay, so now if we base64 encode this, copy this value, and we're going to put it in there. And I'm just going to toggle software app and make sure so there's 3 A's at the end and H4 at the beginning. H4, 3 A's. We're good. Okay. Alright, so this should work. Alright, this is what we need to do. So we need to go back to the application. This has logged us out because I don't know why, but the application is really dumb. I don't know why they need to trash the session each time, but whatever. So we register our user again, and then we log in. Report a bug. Send that. Wait for it to respond. Why is it taking so long? I don't know why it's taking so long. Has it already worked? We can test here. Nope. Interesting. Okay. I'm just gonna resend it. There we go. I don't know why it didn't work the first time. There we go. See, this is how we knew we cheesed it, because the flag literally references deserialization, and we had not deserialized anything. So I still don't know how it's done. I'm pretty sure it is the cookie method. However, the write-up I looked at, I followed it, and it just didn't work. So I don't know. Well, I'll update you if I solve that. Any questions about that? While people are typing, possibly we'll do some more spins. Kettle Bear, you're still in chat. This is your spin. Okay. Kettle Bear, if you're in chat, you get cat time. Select cat. If you're not in chat, we'll let someone select the cat for you. Okay, this is Agent OP. We finally got to you, and you're 10. All right, a chess game against chat. Does anyone want to challenge me in chess? Anyone feeling up to it? Bear in mind, I'm not very good at chess. I just enjoy playing it. Compendium's already too buzzed. Okay. Well, if anyone wants to challenge me at chess, we'll play that. Let's do one more spin. This is Agent OP's second spin. And you won a Privilege Course giveaway. Look at that. Alright, let's get that going. DZ64 is going to play me. Okay, excellent. Alright. Let's head into Hackers Academy. We'll create a new coupon. And we'll do Agent OP as the name. 100% off. Full product. Add. There you go. Okay. Everyone in chat can get that. I'm guessing F it is fuck it. So if you click on that link, it'll still show the cost. But if you go to checkout, it should be it should be $0. All right. DZ64. Do you have chess.com, or would you prefer just light chess? Okay. We'll move on to Spiky Tamagotchi when we'll build it. Hang on. DZ64, yeah, just let me know which platform you prefer to play chess on, chess.com or play chess or something else. Okay, so Spiky Tamagotchi, let's just load it. Let's load it and go. Well, Agent OP, yeah, so this is an interesting one. So, firstly, I don't know what that was. We don't get any credentials. We can't log in. There's no actual register page. We look in the source code. Where is it? Spiky Tamagotchi. We'll do String Raiders in a minute. There is no registration function, even though there is a registration view, I think. Oh, maybe not. There is a reference to registration. Register user, there is. This doesn't get called anyway. You can't even register. This doesn't work. Nothing there. So let's do Stream Raiders quickly. Yeah, we'll just do a 3 minute each side game of chess. Alright, well done. Well done, Christian Compendium. Alright, let me set up the... challenge link. Okay. Okay, if you click that challenge link, you should get to me. DZE. Okay, good. Script. Should have done that. There we go. I'm not doing very good. I'm losing pawns all over the place. I'm trying to go. Okay. Um, oh, I didn't even see that. At least you lose that. Um, mm,
We'll be driving down state, yeah. Looking around for the next crowd, yeah. Going our own way, trying to find a new route, yeah. We'll be going in circles, trying to find a way, searching for
okay.
the things we do, yeah. Dropped out without a choice, yeah.
All right.
Around to the window, singing stupid noise, or will you?
So,
I just wanna get to know ya.
Spiky Tamagotchi, you don't have a login. Sorry I was so quiet for that. I was trying to concentrate. Alright. Yeah, so we can, like, we can type anything in. Oops, password. Right, yeah, we could try guessing, like, admin, admin. But actually, I think if you look at the code, when they set up the database, where is it? Database.js. I think they create a user Docker file, maybe. Yeah. There's the user admin, but the password is random. Okay. So let's have a look at the authentication. I'm just gonna bring my notes up. So we look at the actual login request. It's a JSON object. Okay. And when you deal with JSON objects and Node.js specifically, which is what this is, things can get really funky. So we go to index and we go to the login. It grabs the username and password out of the request body, that's fine. It checks if there is a username and password, again, that's fine. And then tries to log in the user using this db login user. Okay, so let's go to database.js, login user. It takes a username and password. It passes them into this prepared statement. Okay. Now, the interesting thing about prepared statements is they're extremely safe as long as the type of input you're passing to them is what you're expecting. Obviously, when you're doing a username and password match, the type of object that you want to pass is a string. These are strings. That's fine. But what if they weren't strings? So we could try setting them to 0. But that unfortunately ruins everything because apparently when parsing this JSON object, if you have a 0 there, it just says, oh, there's nothing there. Therefore, this check fails. Okay? However, we're on the kind of right track because a funny thing about SQL is that when it does a comparison between a column name and something, if it's a string, it'll look at the value of the column name. And obviously, if the value of a column name is a string, it'll say, okay, well, are the strings equivalent? Right? But if you give it an integer, or something that MySQL thinks is an integer, and the column is a the column is a string, all strings are technically equal to the integer 0. That's just a funny thing. Now, we tried passing these integers, but this didn't work. So, other things in Node.js that equal integers, specifically into the equal the integer 0, are objects. And it turns out, if you do this, in Node.js, those become objects. And now we've authenticated. That is as easy as it gets. The trick with playing with authentication like this is just try every damn thing. Try this stupid thing, and then you'll get in. Anyway, now we have a cookie. We're technically, I'm pretty sure we're the admin user. Actually, we can double check. Yeah, we are. So that's nice. So let's set this session cookie in our browser. Go inspect, go application, session cookie is this. And now we can refresh. Actually, we can't refresh. We need to go to the actual URL, which is interface. So now we've logged in. Now we have a Tamagotchi. And we can feed the Tamagotchi. And if we feed it, I think its health goes up and its weight goes up. And its happiness maybe goes up. Blah, blah, blah. We can do all this stuff with it. But the key thing is, it's posting to this new API that we have. Okay. So if we feed it, and the values of health are 61, 47, and 53, then we get the mood becomes awkward, and we get 62, 52, 56. So let's look at this code. So where's the API? Here we go. So it passes these values to Spiky Fact to calculate. It looks like we cannot inject into these integers because we can't turn them into anything else because they are integers always. They're parsints. But we can probably inject into this activity. Let's open up spikyfactor.js. And we get this thing. This is a weird thing, and I didn't even realize these existed. But this is, I believe, called a tagged template. I had to look up my notes. This is a tagged template in JS. Node, sorry. And what it's doing is it's setting a variable locally within this kind of function. It's almost like a lambda function in Python. It's setting it equal to the activity we passed, right? And then it's using it here and here and here. Template that, yeah, but they're tagged template results. This is apparently what it is. So we can play around with this, and honestly, I didn't even know anything about this. So the way I got this was just messing around. So the first thing I did was I want to not mess around with these values, so I'm going to set them all to 0, and then we know what happens. We can just track easily. So if we feed our Tamagotchi when it has its health at 0, its weight at 0, and its happiness, we get 11, 10, 8. Okay, and that's always going to be constant. And if we start injecting, maybe just put like a thing there, we get something went wrong. If we put another one, we get something went wrong. So what you can try is, I think you can do something like this. Yeah. So what we've done there is we've basically done a concatenation. So if you imagine, let's look at this A here. If this A is pretty much like that, and then we put our value in, well, this is still true. Yeah? So that's fine. So we can take some liberties. We know that all of these A's are effectively, we can imagine them as being surrounded by quotes. By single quotes. So what else can we do? Well, so let's just do this. We have this. This is our value that we're injecting. So can we do anything else? Well, I guess what we could do is we could do feed equals feed, and then do ampersand 1 equals 1, ampersand feed, right? So we got if feed equals feed and 1 equals 1 and feed equals feed. So we take all of this. This is the stuff that's inside, and we're going to try it in here. And remember, our values are 11, 10, 8, and again they're 11, 10, 8. And what happens if we change this 1 to 2? Now they're 5, 10, 5. So we have a kind of Boolean-based injection here. Every time we send 0, 0, 0 with this 1 equals 2, we get 5, 10, 5. If we send it with 1 equals 1, we get 11, 10, 8. Interesting. So what else can we do? We should check if we can eval, right? So can we surround this 1 equals 1 with just an eval? Because an eval of 1 equals 1 would just return a true, and then it would be if feed equals feed and true and feed equals feed, which is obviously going to be true. And it turns out we can. We'll double check it. When you're doing this, always double check. But if you find a Boolean injection, always make sure you're making a false Boolean statement to double check it's still changing stuff. So we can get inside an eval, which is interesting. Because doesn't that mean we can just do something like require, what is it? / this child process, right? And execute, because this is Node.js. Turns out we've got unexpected. Oh, that unexpected C. There we go. But if we try this, we get something weird. We get something went wrong, and this bugged me for ages. And then I realized, why am I even dealing with this online? I should boot up the code. I was doing this against the actual box. But if you boot up the code and look at the actual error, what I had to do here was, in this catch E statement, I just added this. So I added console.log E, and I rebuilt the Docker. And then I can see what this exception is, right? When you get the something went wrong. And it turns out this exception is saying reference error require is not defined. Right? Which is odd. Not defined at eval. So let's Google that. And then we get, I'm just obviously speeding this up, but I think, is it this one? Yes, okay. Eventually, a bit of Googling, I found this thing. Because I found a lot of reference errors with just regular JavaScript, which obviously this isn't. This is Node.js. But this guy's answer was incredible. So he said, well, you can set required to global.require or global.process main module constructor.load, _load. And then you can just use it. Really? Like, it's that simple? I mean, let's try it. We'll put that there. And suddenly, like magic, it works. And now you can just do .exec. But you cannot, I don't think you can, maybe you can sleep 5. No, you can't sleep 5. Read the comment on it. Oh yeah, security hole on our API server, I saw that earlier. So, we try a sleep 5 and it doesn't do anything. But it doesn't return an error, which is odd, right? Until further Googling, you realize that this exec is actually asynchronous, so it's not going to return anything. If it's sleeping like this, it won't return. So this should get run, but it just won't return. So that's okay, because of course we have wget, right? So we'll go to tab eraser. I'm going to clear this out. Create a new payload. Where's the flag? The flag is /flag again. So we're just going to do this. We're just going to use wget http that flag equals, and then we should be able to do base64-w0 flag.txt and save. And that seemed to have worked. If we poll now, look at that. We get what I presume is the flag. Put it in here. And it is. Okay. Any questions about that? Okay. I also want to point out I'm doing this all very, very fast. Looking like some kind of Uber hacker when in real life this took fucking hours. This took hours and multiple people. As I have said repeatedly in this stream, most of these I didn't get on my own. Some of them I did. Most of these I got help from people like GoPro Sloyo, who's in chat. And my team. This is why I always recommend, if you're doing a CTF, join a big team and just spend stuff. Yeah, you can spend 5 hours on this easily. I think we may have spent 5 hours on it. It was that the last thing, this realizing that this caused an exception if you didn't have this crap took so long, and then actually it was Al Hazred who was like, well, does require even exist? Like, how can we check? And that gave me the idea to put a console .log here, and then we realized, oh, actually, damn. All right, moving swiftly on. Do we have Stream Raiders yet? No. All right. We're moving. So the last two, Genesis Wallet. Oh boy, Genesis Wallet pissed me off. So, Genesis Wallet was a 3-star, so it was the most difficult. And then there was a Genesis Wallet Revenge, which was also 3-star. And it turns out, and we didn't realize this till afterwards, the first Genesis Wallet was supposed to be done a certain way, but there was a massive gaping hole, which meant that you could easily get the flag another way if you noticed something obvious. And so that's why they created the Revenge. The Revenge one was patched. Now, we didn't find the easy way. We did Genesis Wallet the intended way, and then we did Genesis Wallet's Revenge, and we're like, wait a minute, the same exploit works. what gives. Because we got Genesis Wallet after maybe 3 hours, and then we got Genesis Wallet's Revenge in 5 minutes because it was literally the same thing. And so then we diffed the code, and then we saw. Only after we diffed the code did we see, oh, they fixed that. And then I was like, no, that can't be right. And then we tried it, and yes. Well, so what I'm going to do here, so I'm not doing the same thing twice, I'm going to show you the unintentional way to solve Web Genesis, which was so ridiculously bad. I can't believe they actually missed this. It's funny, but it's kind of like, wow, you actually missed that. And then we'll solve Genesis Wallet's Revenge the proper way. All right. So let's load this. Make sure it works. Okay, good. So let's close all this and look at the code, because the code is interesting. The code is going to tell us some good things that we need to know. Okay, Web Genesis Wallet. Obviously, we have a flag. We have a Docker file. Great. Flags at /flag. This doesn't really tell us anything. This was nothing. If we go to index, there's nothing there. Database is interesting because firstly, it gives us Icarus's password, which you think, oh, okay. I can't go Pro Slayer because Red Island didn't have a download, which I'm really annoyed about. So we see there's one user in this database. It has Icarus. The password is fly high to the sky, and they have leet.10, I guess, dollars in their balance. They have this OTP key, which apparently this generates a random one. So we don't know that. This address, the address of this wallet, is a MD5 hash of Icarus. In hex. Okay? So that's easily gettable. So we know 3 things about Icarus. We know his username, we know his password, and then we know his wallet address. So let's try logging in as him, right? We're just thinking, okay, Icarus. Submit. It's easy. Oh, wait a minute. There's a one-time password thing. We don't know. So let's keep going. We can register users, log in, set OTP key, get OTP key, list users. Okay, add transactions. Interesting. List transactions. Blah blah blah. The bot every 5 seconds, I think, visits the transactions page. So that's interesting. If we go to routes and then go down to, I think it's dashboard. This is where it gets interesting. The dashboard is where you go when you log in. And so this line is weird, right? This says if the user's balance is greater than leet and their username is not Icarus, then set flag to file system read file sync /flag toString. Okay, so it grabs the flag if our balance is above leet, but our username isn't Icarus. But Icarus has leet dollars, right? So that's a bit weird. And then it loads the dashboard and passes the flag. So if we go to views, EN dashboard and search for the word flag. Oh, okay, I didn't mean to do that. Hang on. Dashboard flag. There it is. So we know how to get the flag. We just need to get leaked dollars. right, and not be Icarus. So let's register. So register. Account registered successfully. And then we go to login. Commit. Okay, so now we have a two-factor authentication code, which I just need to scan into my phone. So, don't mind me. We'll do a battle in a minute after I've scanned this. Okay, so I've scanned it. I click I saved it. And the code is 752475. Okay. Oh, I didn't even write that, I guess. 752475. Submit. And now we're in. And we only have a balance of 0.1. So we aren't seeing the flag. Okay, our username is not Icarus, but we do not have a balance. Okay. So let's just do stream radios quickly. Got a lot of people in the stream raiders. That's nice. Thanks for stopping by. Gugo. I didn't say you pronounce your name. Make sure to catch the VOD. The bits you missed. Alright. Okay, good. Well done, Ghost, Spooky, GoPro Slow, and Christy. We're almost at the boss. Okay, back to this. So we can send transactions. We obviously need to know their address and the amount to send, and we can leave a note. So let's have a look at the send logic. So there should be a post API transactions create. So what it does, it checks whether the user's balance is less than the amount we're sending. And if it is, which says insufficient funds, it checks whether the address is valid that we're sending it to. And finally, it checks whether the address is the same as our address, because you can't send to your own address. Is there anything in here that you think it should check for that it's not checking for? Maybe if I scroll down to the verify. There you go, Winzen. Is it negative? It doesn't check if the value is negative. So we have Icarus's receiving address. We'll send ourselves that much. Negative, we'll send him, sorry, negative 1337. We'll submit it. It's currently pending. I need to type the... Oops, I'm not even typing. 696690. That's the one-time password. And then if we go to the dashboard... Oh, look! There's the flag. This was a level 3. This was the hardest one. And they left that flaw in it. And the tragic thing is, only like 100 people got this one. Even this easy one. I think they should have, honestly, when they discovered the flag and they discovered the flaw, they should have put it down to a 1, so that more people had tried it. So many people didn't try this one because they saw it was a 3 and they thought, well, it's a 3, it's going to be impossible for me, so I'm not even going to try it. So I'm kind of annoyed that they didn't. Yeah, you didn't look at this one because it was a 3, and you were thinking, well, I'm not very confident at 3. Yeah, I'm glad they fixed it, but they should have put it down to a 1, and they should have announced it and said something. Anyway, so I don't think there's any questions about that, right? That's pretty freaking basic. So let's see how it was supposed to be solved, because the way it's supposed to be solved is just beautiful. And it uses a technique which I have talked about on stream before, but rarely comes up. And this is the way I solved this Web Genesis board the first time. So, the thing to note in here, in the Docker file, is it installs something called Varnish. And it also, there's in this config, there's a cache.vc. Okay. Now, Varnish is a web cache. What's a web cache? A web cache is a device that sits between the user and the web server, and it processes the HTTP requests before they reach the web server. And based on the HTTP request, it'll make a decision. Should I ask the web server for a file, right, for the response and send that? Or should I look in my cache and return a cached file? Or should I ask the web server for the response, return it, but also cache it for future users? Okay? There's the 3 things it can do. And it tells us what it'll match on, right? So only allow caching for get and head requests. So it will only return, it'll only query its cache if the request coming in is either get or head. That makes sense. Get JavaScript and CSS from cache. So JavaScript and CSS do not change that often, so they can usually be cached fine. So if the URL ends in .js or .js with a version, or .js with I'm not entirely sure what, no, with a question mark T, then you can return that file from the cache. Same thing with images. If it's an SVG, ICO, JPG, JPEG, GIF, or PNG, return it. If it's a font, sure, but everything else, grab from the backend. This is reasonable. There's no exploit here. All right. And this is all fine. This is actually a perfectly valid cache file. So the vulnerability is not there, but what's weird is it is there, because no other challenges use this. So why is it there? Well, let's sign up and see. Okay, again, we need to add this. Okay, I've saved it. And the OTP code is 823354. So we're at the dashboard. So let's go back to that routes file. And where's the dashboard? Here. For the dashboard, you see anything weird? about this. So this is post API two-factor authentication verify. This is a string. This isn't a string. This is a regular expression. Okay? These are all regular expressions. This isn't. This is API transactions create. This is API transactions verify. This is a string. But these are all regular expressions. And more notably, they're all regular expressions where you have a caret symbol at the start, which means start of string, match the start of the string. But you don't have a dollar sign at the end. This is a gaping hole. This means as long as the URL begins with whatever this crap is. This is just words, optional words, if that. If it has a transactions, right, then return the transactions page. This pretty much means if the word transactions appears anywhere in the URL, return the transactions page. And the same for dashboard, right? The dashboard was the same. So dashboard returns it, but so does dashboard A. So does dashboard dash test. So does dashboard.jpg. Oh dear. What does this mean? We've asked for dashboard.jpg. What's the first thing that's going to process this request for dashboard.jpg? It's the Varnish server. And the Varnish server knows if a request ends in .jpg, well, return that from the cache. But obviously, when we request dashboard.jpg, where is it? Subject to pizza. When we request dashboard.jpg, the Varnish server is like, well, I don't have dashboard.jpg. It's a cache miss. There's no hit on the cache. So here you go. Here's dashboard.jpg from the web server. Right? But now, if we send another request to dashboard.jpg, oh, it's a cache hit. This didn't come from the web app. This came from the cache. The Varnish server cached this response as an image, thinking it was an image, and when we requested it, it returned it. And of course, the Varnish server doesn't care about cookies. We can grab this dashboard.jpg, which has all of my logged in information without authenticating. Does that make sense to everybody? So, how can we exploit this? Well, it turns out that the transaction functionality also contains some XSS. Well, not really XSS, it's a kind of very basic HTML injection. It allows some HTML tags. We go to the helper, the MD helper. It allows strong tags. You can use strong tags. You can use EM. You can use image, A, S, UL, OL, and LI. But you can only use these tags with their basic arguments. So you can't do an image on error. It will remove the on error. You can do an image source because source is considered a standard argument for an image. And we can send these to the Icarus user in a transaction, which means we can link him to an image, which isn't really an image. It could be dashboard.jpg, and that would cache it, right? So is there anything interesting we can do with this app which we could get a cached page for? Well, if we go to settings, we can do this, set new OTP key. And if we go down here, when we visit reset 2FA and scroll down, we get this gen QR code. And this gen QR code redirects us to this, which then generates an image, which is the QR code, right? So, to attack this, what we need to do is we can go back. We don't even care about that right now. We can go send. We're going to send Icarus to this page. Where's Icarus's key? It's here. We're going to send him 0.0001. I'm just going to make sure this actually renders. So what's going to happen, we're going to send it. It won't actually work right away because we have to verify it. Let's intercept it. Send. Make sure it looks good. That looks good to me. Okay. We're going to forward it. Turn the intercept off. Okay, it's in a pending state now. So now what we can do is we can confirm this transaction. 932.649. Oh. Oh, okay, because my hang on a minute. I overwrote my own key. Hang on. I need to. This actually overwrites your key. So I need to request in the current browser session. Authentication. Okay. Okay, hang on. Let me go to settings. Set new OTP key. Let me take a scan of this. Okay, saved it. Transactions. Pending. 724494. Okay, transaction's gone through. So, hopefully, he's now hit. Where is it? He's now hit this URL. Okay, and cached it. So now if we go to it ourselves, okay, it's done that. But let's have a look at the request. That was a miss. Hang on a minute. Why did it miss? That shouldn't have happened. Okay, I'll tell you what we'll do. We're gonna verify that he is actually grabbing it. This is where the last one friggin' fails. Hang on. I'm gonna scan this QR code so that it's ours. Okay, I've saved it. So what we're gonna do, we're gonna resend our initial we're going to resend this, but what we're also going to do is we're going to put in a tabulator command. So we're going to enter another image. so we know when he's viewed it. Okay. Open that as well. Because this should definitely work. But we'll see. Let's go send. And then obviously we need to go to transactions. We need to go here. 267508. Verify. Okay. Collaborator. Poll now. Okay, we did get a hit. So I just want to double check. What I'm going to do is I'm going to just put this here. Oops. We'll use repeater this time. And we'll try just doing this. I don't know why this isn't working. This was working last night for me fine. Oh, I know why. It should be this. I'm an idiot. Yeah. So actually, we need to change this. Right? Yeah. That was the issue that was tripping me up before. For some reason, I forgot it was 127. All right, he's not going to localhost. He's going to 127. All right, so we'll send this. And then we will go to transactions, pending 671272. Oh, yeah, that should be fine. Okay. Verified. We should get a hit on our Taberator server. There we go. Okay. So now, if we go to this URL in our browser, why? All right. Yeah, we need. No. What? Is it this one? Just that? No, that's still not working. There's something weird going on here. Let me just double check something. This is a really cool exploit, but getting it to work is apparently a pain. Oh, he's not going to leap. Alright, it wasn't even that. So he's not even browsing to the freaking 1337. Okay, 5th time's the freaking charm. So we're gonna go here. And also that means we're gonna have to... Yeah, this should work. Okay. Cool. I'm just trying to figure out something. Yeah, okay. So I'm going to copy that. I'm going to do it a slightly different way. So we're going to send that again. We're going to go to transactions. This one was so finicky. It took us freaking hours. 263. Verify. Well, now what I'm going to do is I'm going to click this, but I'm going to intercept it first. This was a much easier method. Okay, so it's going to reset 2FA. We want it to go reset 2FA.png, and we want it to go here, right? So if I forward that, intercept off. So if we go down to here now, when we grab this, there was the hit. So this was the hit. This is a cached page. This is the bot user Icarus's new code, which is now displaying in our browser. So I'm going to scan this. I've saved it. Okay. Now we're going to do a new window. 1337. Grab Icarus's password again, which is in the file. Where is it? Database. Okay. Go here. Icarus and his password. hopefully this freaking works. Here's the code on my phone is 727638. Verified. We are now Icarus, and we have a balance. So now, if I go back to my original thing, I want to receive some money, please. So we copy my wallet address, go back to Icarus. We're going to send me 1337.0, owned, send, go to the transaction, enter our code again, which now just changed 037743. 03773. Did it reset again? We may have to do. I may not have been quick enough. We may have to do another reset. Oh, actually, we can just do it here. We're already him. So let me just set a new OTP key. Okay, so that's set. I've saved it. Yeah, it did reset it. Okay, transactions, pending, 727266. Correct, good. Go back to here. Not there, sorry, this one. Go back to our wallet. Refresh it maybe. And there's the flag. Any questions about that? Other than, what is this exploit and how cool is that? And the answer is, this is web cache deception, and yes, it's amazingly cool if you can ever find it. It's really rare. And again, the caching server is just doing what it's been told to do. There's nothing wrong with the caching server's config. The problem is when you set up routes in a web app and don't properly end them if you're using regex. If you just say, oh, match the first bit, I don't care what comes after, you are setting yourself up for a world of pain if you use a caching server. Because attackers could, you know, just cache anything really if you can send a link. If you can get a user to click on a link to dashboard.jpg, it'll load their dashboard and then the attacker can just grab their dashboard. So yeah. Any questions? That was it. By the way, that's pretty much all I had. Yeah. So we have a bunch more spins. I think we'll just save them for another stream. We have like 17 spins to go through. So I think it's probably easy if we just save that for another stream. Kettlebell had cat time but didn't get back to me, so we'll do cat time next time. Otherwise, it's been quite a long stream, 4.5 hours already. So we'll do our last stream raiders. We'll do a last marble game, and then we will find someone to raid. Does that sound good? If you have any questions about any of the things that have been on the stream so far, please let me know. You can always join my Discord server. So do that. And if you wanna reach out to me afterwards, that's fine as well. But yeah, let's start the battle early. Stream Raiders. Like I said, we'll do one marble run, and we'll find someone to raid. Should always be good. Thank you. These are hardly write-ups. They're more like virtual write-ups. I might edit these videos into separate videos, I guess. That would be kind of fun. Oh, Anya's online as well. We'll raid Anya. Assuming she's still online. And just see. How long has she been streaming for? "25 minutes. Great, we're gonna raid Anya. Alright, we will do marbles. And yeah. Hopefully that was entertaining for you. Hopefully you learned some stuff. I had a blast doing the CTF. This is the most fun I've had doing a CTF in a while. So, Hack the Box just knocked it out of the park. They really did. There was stuff for everybody. All right, well done, Ghost of Spooky, the Hazy Cracker, and Go for a Slow. All right, let's do marbles. Random track. Exclamation point play in the chat if you want to play. This one has a music video. Oh, we've done this one before, I think. This is crazy. All right. I think Oreo Bite, you may have to re-enter. I think I said that too slow. Here we go. All right, 60-second countdown. Exclamation point play in chat if you want to play marbles. Thank you so much for coming to the stream. I know it wasn't an ordinary Frustration Friday, but hopefully I could share my frustrations with you. Because like I said, I probably spent a good between 24 and 48 hours on this CTF this week. It was freaking crazy. It took my entire weekend and then some. But it was worth it because we came 23rd. And the web app challenges were hilariously good. Really, really major thing. Alright, last chance, 10 more seconds. Exclamation point play. Alright, here we go. Those sound loud. Well, oh my goodness. Can't tell who's first. I think Ricard's first. Yep. Oh no. F's in chat for Ricard. Is that like volume really loud for you guys or not? I need to know if I need to turn it down. It sounds loud to me, but... Oh no! F's in chat for Agent OP. Oh. We got no thing now. Going down his spinny. It's loud as fuck. Yeah, okay. I think that's the last... Oh no, it's not. Let me, I feel like I can turn this down. I think I need to like escape. Let me see if I can quickly do it. Is that better? I think I saved it. Well, who's the... Oh, what's that? Who are these people? Who won? No, nothing won. Alright. I need to make sure I turn down the volume on this, apparently. So many people died. Bye-bye, Real Eagle Slam. I salute you, sir. This is just like... That's like a... 2/3 of people just died. Alrighty. No questions, that's perfect. Great. Thank you so much again for everybody coming coming along. Thank you so much for all the freaking subs. That was insane. I'm glad we did manage to get to the giveaway. Please stay for the raid. Anya Askey is a great streamer. She's doing a lot of good stuff. So she's definitely worth a watch. On the screen are my socials. Please follow me on Twitter. Please join my Discord server. Subscribe to the YouTube channel. And if you're not following me on Twitch, why aren't you following me on Twitch? Please follow me on Twitch, and you'll get notifications when I go live. We will be back on Monday for Cyber Mentoring Monday. Easy boxes, beginner content, friendly stuff. Okay, but in the meantime, thank you so much for letting me share my passion with you guys, especially the crypto stuff, which is probably very boring. But yeah, I hope everyone has a great weekend, and I will see you on Monday.